Hello, good morning all. Welcome to the global webinar on applied science, engineering and technology. This is Nawaz Sheikh today, and I welcome all the participants to this conference.
Yes.
Our first speaker today is Darius from Koszalin University of Technology, Poland, and he is going to give a talk on reconstruction of multidimensional data on intelligent technology and artificial intelligence. And I request Dr. Darius to start his presentation.
Did you share my screen? Okay, so very good morning from Poland, from Koszalin University of Technology. And I will speak about some mathematics about reconstruction of data, of multidimensional data. Koszalin is not very big city, 100,000 of people. We have some faculties on our university, and my department is Faculty of Electronics and Computer Science. And Koszalin is on Baltic Sea. Here is Baltic coast. Here is Koszalin, and mathematically, I can say I will speak about reconstruction of data. We can say interpolation and extrapolation. Yes, in 2 dimension. For example, if we have some cities, and if we draw a straight line, we have the simplest linear interpolation. Yes, but of course on the map we have some more cities, but we didn't see them. And if we want to model some curve between 2 points, yes, modeling of data between 2 points is interpolation. And in classical interpolation we have, for example, polynomial. Yes, polynomial interpolation between some points. We have interpolation points as nodes. It must be some important points. For example, maximum, minimum. But polynomial is not always very good. Yes, how to model about with another method. And in my method, I will speak about modeling about interpolation between two points. Yes, we have coordinate x and coordinate y. Between 2 successive nodes, we can calculate each point between x1 and x2, for example, by parameter alpha. It's first coordinate. But what about second coordinate, about our data? And first half, if we cut here, first half is almost the same like coordinate x, but here is function gamma. Yes, if gamma is alpha, it is linear. It is linear interpolation. But gamma can be any function for interpolation, such as in zero gamma is 0, and in 1 gamma has value 1, and it is strictly monotonic. Yes, first part. Second part, assume combination of nodes. P1, P2, it's our interpolation nodes, and here can be combination of nodes. The simplest combination is 0. Yes, if second part is 0 in the simplest way, and yes, in the simplest way we have modeling of second coordinate between two nodes. And as I said, gamma is any function, yes, with alpha 0 it is value 0, and for alpha 1 value is 1. Yes, we must value in interpolation nodes very strictly as the beginning. And of course, this modeling function is a huge number. Yes, for example, power function. Yes, if S is 1, it is linear. Yes, if gamma is alpha, it is the simplest linear interpolation. But other parameters S give us other modelings, other possibilities of modelings. Yes, so between two successive nodes, we can model our data in two. Here is in 2 dimension, but it is possible in any dimension. Third coordinate, fourth coordinate. Yes, we can also model in our function. Sorry. It is some examples of classical interpolation, and polynomial interpolation is not very good. Yes, for example, function 1 divided by 1 plus x power 2. It is a red function, but polynomial interpolation, yes, black polynomial is quite bad. Here also we have this example on bottom. So I modeled this function, and many applications are such that we must have smooth function in each node. And here I have four nodes for x minus 1, minus 0.5, second node. Third node is for 0, also 0, and fourth node is x1. And I interpolate, I modeled some points. Yes, left part is between -1 and 0, and left part is modeled for such a sinusoidal modeling function, and left part has parameter s, like here, to have very little error. Yes, I calculate value of second coordinate, and here is error compared with exact values of this function for this point, 10 points, and I assume this error. And right part is also sinusoidal modeling for another parameter s to have such an error. And on down is polynomial. Yes, we have 4 nodes, and polynomial is rank 3. Here is this polynomial, and for left part, polynomial is not bad comparing errors, but for example, right part is polynomial has big errors in this point, and my method has less errors. Yes, and how I have, for example, smooth modeling between x-1 and 1. I compared, yes, to calculate this parameter s and to have smooth modeling in node x0, I compared left and right derivative. Yes, I calculated these parameters s to have equal left and right derivative in 0. Yes, to have smooth in 0. If our application curve is not smooth, yes, we have some examples of applications when curve is not smooth. If curve could be is not smooth in 0, interpolation is better. We have less errors for modeling points, for this modeling with such s. Yes, to have less errors. Why polynomial error is could be very big? This is formula for polynomial modeling, and polynomial errors. Here we have derivative rank n+1. Yes, for if we have n+1 nodes, derivative rank n+1 is in the formula of errors. And for example, 2 power x, it is okay. Here we have derivative of this function, and for nodes x 1, 2, 3, 0, to power x is not very bad. But for example, a power x, yes, here is derivative of exponential function a power x, and it is very huge. And second classical example is function y divided by x. Yes, also here I have 4 nodes. 4 nodes for x 0.5 is first, 2 is second, and 4 is third. And polynomial is for this nodes is quite bad. Yes, and here are errors. For example, right part of polynomial. Yes, right of x equal 2 is quite bad. Here is huge error. And some points modeled by power function for such parameter s has less errors to have smooth in the node 2. If not smooth, yes, interpolation is better. And last example, absolute value function. Yes, if we take 4 nodes, -2 x -1, here is 0 and x1. Polynomial is not to used, but in this case our method gives us alpha and linear interpolation gives us absolute value function. Yes, of course we can have for separately left. We can say if we take separately left part and right part, we have linear interpolation. Yes, but having all together 4 nodes. Yes, for these 4 nodes we have polynomial, but these 4 nodes gives the simplest linear interpolation. Comparing of errors for polynomial, and as I said, exponent, there are no ideal method. Yes, for many function, for example, exponential function, yes, polynomial error is quite good. Yes, better for my modeling. But in this classical examples, for this function, there were 20 interpolated values, and sum of errors give us 2-point smooth interpolation error when a curve is smooth in each node, and better interpolation but not smooth in all nodes. Of course, we can have cubic splines, but in polynomial, also in cubic splines, we can have extremum between the nodes. For example, for this function in 3 nodes, we have such cubic splines, and extremum is not very good. Yes, if in 2-point smooth interpolation we don't have extremum between the nodes. And so this modeling, we can say, is parametric form of curve. Yes, we have parameter alpha between 0 and 1, and we calculate first coordinate, second coordinate and n coordinate. Yes, explicit representation is function in 3 dimension, but of course there are some bad features with if we have simply vertical line of another curve. Yes, in my proposition, no matter that curve is open or closed, we have parametric representation. Yes, so we have modeling of first coordinate, second coordinate, yes, third coordinate z, yes, also could be modeling between z1 and z2, for example. No matter if the curve is opened or closed, so it is not only function, as in classical mathematical interpolation, we have only function. Yes, in computer graphics, in image processing, we can model a curve also closed as a contour, for example, contour of some objects. And what about values outside? Yes, outside the nodes. If we take alpha from range 0, 1, we have interpolation. Yes, and if we take parameter alpha less than 0 or bigger than 1, we can calculate values outside. We can have extrapolation. So we have parametrization of curve and choosing modeling function. For example, we have here 5 nodes. For this modeling function with this parameter, we can model our contour, our object. So contour, for example, could be a human body, yes, contour of human pose in biometric, or modeling of fingertips, of curve on fingertips. And as I said, n dimension, third coordinate z, fourth, and so on, also, yes, also could be modeled by modeling function gamma. So we can calculate our pixels, for example, grayscale in image zooming, warping. Yes, for example, third parameter could be at grayscale. Yes, a grayscale, and in image interpolation and, for example, data reconstruction, image retrieval, it is possible to calculate a grayscale between two pixels. Yes, in a numerical analysis, calculation of values, as I said, extrapolation, curve fitting. Yes, we can fit our curve between some points. And yes, ending here are some of books when you can find this material. Last book, analyzing data through probabilistic modeling in statistics, also is finished, and it can be found via this link. And my city, here is Baltic Sea, cathedral, and my university. So thank you for attention. Yes, and if there are some questions.
Thank you so much, Dr. Dorius. Thank you for the excellent presentation. Yes, our next speaker for today is Dr. Prajna Kunche from Indira Gandhi Center for Atomic Research, India, and she's going to give a talk on recent advances in acoustic emission signal processing. And I request Dr. Prajna to start her presentation.
It's a very good morning to one and all. And today I'm going to present the topic of recent trends in acoustic emission signal processing. And I am Prajna from Indira Gandhi Center for Atomic Research. So, well, acoustic emission is one of the best techniques into the field of non-destructive testing due to the uniqueness of its basic principle and also the potential for tackling a wide range of applications. But some of the state-of-the-art acoustic emission techniques uses very simple measurements and analysis methods. But the entire potential of the technique still remains to be exploited, since the extraction of the complete information of the signal is not possible with the use of or adopting the simple methods or measurement analyses. So currently, several scientists in many countries are involved in evolving and implementing advanced concepts for AE signal analysis or signal processing. Along these techniques, the approaches adopted by us are also discussed in this talk. So this is the brief introduction to the acoustic emission signal processing or acoustic emissional signal method. In AE waves or the pressure waves that are generated due to the transient release of energy within a material when it is subjected to mechanical changes or thermal changes or chemical changes that causes irreversible deformations in atomic arrangements. So let us suppose this is the material which is under the load or stimulus, then the crack will be generated within the material, and due to the crack, some AE source, AE signals will be generated. Those are nothing but the transient signals, and those will be radiated in all directions. And these generated signals transmit towards the surface of this material, and a sensor is mounted or placed using a couplant on the surface of this material to detect this generated AE signal from the source of this material. That AE signal is given as the input to the AE instrument. Generally, the AE instruments are the portable instruments which are used for the field testing, and the AE instruments consist of primary components such as sensors, preamplifiers, and signal processors. Sensors, as I said, they are used to detect the AE signal from the AE source, and AE sensors or generally a piezoelectric type contact sensors will be used, and preamplifiers which are used for amplifying the initial weak signals, because in the transformation or transmitting process they will undergo several phenomena like attenuation, dispersion, diffraction. So the signal may get weak, and preamplifiers are used for this purpose, and the signal processors performs the basic signal processing operations like filtration and data analysis. Coming to the characteristics of the AE wave, AE fracture in materials takes place with the release of stored strains energy, which is consumed by nucleating new external surfaces and emitting elastic waves which are defined as AE waves. AE waves are not sonic waves, but they are elastic waves in solid. So they radiate energy in all directions, and the frequency ranges are we can detect a AE signal below 100 kilohertz, and it will be up to few megahertz, for example 5 megahertz. So the basic types of AE signals, AE sensors can detect two types of AE signals. One is burst type AE signal, and another one is the continuous AE signal. This is the example for the waveform of burst type AE signal, and is the example for the continuous AE signal. So these are the sources of acoustic emission. Acoustic emission signals will be generated because of the different phenomena that occurs in different materials. Like materials, it will occur because of crack initiation or fractures or dislocations or melting or twinning or phase transformations. Or in composites, it may occur because of matrix cracking or fiber breakage or debonding. Or in non-materials, it may occur because of the friction or leakage or the knocks. So these are the parameters of the AE signal, which are also called as the features of the AE signal, which are used to determine or characterize the AE, or characterize or locate the AE sources. And the parameters are mainly AE hits, peak amplitude, rise time, duration, energy, and counts. AE hits means transient portions of the measured AE waveforms which satisfies a given detection criteria. Here, this is the waveform of the AE waveform, and here we can see how the parameters are related to this waveform. The maximum amplitude of the waveform is nothing but peak amplitude, and here there is a threshold And the number of pulses that crosses the threshold are called the counts of the AE counts. And here the time from the first AE pulse that crosses the threshold and the maximum amplitude is called the rise time, and the time from the first AE pulse that crosses the threshold and the end of the last pulse that crosses the threshold is called the duration. And here on x-axis it is time, and on y-axis it is the voltage. When energy is nothing but the maximum area that is under the envelope of the digital signal from the transducer. Coming to the real world applications of the acoustic emission technology, here these are the main important applications. One is health monitoring of the structures, behavior of materials, and laboratory and R&D studies. Chemical applications or their power applications, and manufacturing process will also be monitored using this NDT techniques or acoustic, in particular acoustic emission techniques. So as an example for health monitoring structures, we can see the periodic testing of pressure vessels, pipelines, bridges, and cables. And as an example for behavior of materials, we can see the crack propagations, yielding, and also the corrosions. And for R&D applications, the vessel testing, nuclear component inspections will come under the examples for R&D studies. And for chemical applications, storage tanks, reactor vessels, offshores, or will be considered for chemical applications. And for power applications, the inspection of nuclear reactors will be considered as an example for power applications. So the AE signal processing can be summarized into the specific following tasks, such as signal enhancement, signal separation, propagation channel identification, source location, and source characterization. So in this AE signal processing state of the techniques, I just want to mention here, for first one, source location, the wavelet method is the basic conventional method which has been used, but recently the neural networks are also used to estimate the AE source coordinates. And the time difference of array method means TDOA is also used for source location, and beam forming methods are also being developed, and support vector machines are also being developed for source location signal processing. And recently the deep learning techniques are emerging in any field of signal processing. So those are also applied for this AE signal processing. In particular, statistical denoising autoencoders has been developed for AE signal source location technique. And coming to the source characterization, as I said, time difference of arrival TDOA and enhanced TDOA methods have been applied. And some of the optimization techniques like fruit fly optimization technique has also been studied in source characterization. And some of the pattern recognition of AE signals or the conventional wavelet analysis and unsupervised techniques like K-means clustering, and deep learning techniques also been applied as deep transform learning, and basic backpropagation neural network can also be used for pattern recognition of AE signals. Coming to the analysis of AE signals can be analyzed in 3 different domains. One is time domain or temporal domain, frequency domain or spectral domain. Third one is time frequency domain. In time domain, the amplitude or RMS values will be used to analyze the AE signals, and in frequency domain, the FFT of the signal will be used to characterize the AE signal, and in time frequency domain, wavelet analysis will be used. Some other techniques are also there in time frequency domains, which are going to be discussed later. So this is my recent work on acoustic emission signal processing. As we said, acoustic emission signal processing is a well-known non-destructive testing, which is used for inspection of many industrial purposes. Because of its advantages, such as high sensitivity, early and rapid detection of defects, flaws, cracks, defective area location, cost reduction, real-time monitoring. But the main limitation comes that it has loud service environments. That is, it is very noisy backgrounds when we test these acoustic emission signals and record those signals. And the other one is qualitative analysis of results needs some other NDT techniques. So we mainly focus on the main limitation of loud service environments, and because of that we adopted 3 noise reduction algorithms. Basically, for any acoustic, any signal processing, the noise reduction, after that feature extraction and data classification are the main three things need to be developed. In noise reduction, we developed 3 algorithms, and for feature extraction, we used Mel frequency substitute coefficients based technique and feature fusions. And data classification, we use neural network based classifier and also evolutionary neural network classifier. But today's talk, I would like to discuss about the 3 noise reduction algorithms and 1 neural network or pattern recognition for data classification of AE signal processing. Before going to the algorithm, let us see what are the main causes of the AE signal noise or the types of the AE signals. It can be characterized into 4 things. One is hydraulic noise, mechanical noise, cyclic noise, and electromagnetic noise. Hydraulic noise exists in cavitations or turbulent flows, boiling of fluids and leaks, whereas mechanical noise exists because of the pressure vessels ignite their supports caused by elastic expansion under pressure. In cyclic noise, we can see the cyclic noise in rotating machines. And electromagnetic noise is the disruption of operation of electronic device when it is in the vicinity of the electromagnetic field. So coming to the existing enhancement techniques, these are the existing enhancement techniques that are available in the literature so far. So optimum Wiener filter, wavelet denoising method, iterative morphological filter, independent component analysis, empirical mode decomposition, singular spectrum analysis, discrete fractional cosine transform, Kalman filtering, and particle filter for acoustic emission, power spectral subtraction filtering are applied for enhancing or denoising the acoustic emission signal so far. And we proposed another enhancement method, which is based on the fractional Fourier transform technique and also the adaptive noise cancellation for acoustic emission signal. This is our algorithm 1. And this here fractional Fourier transform means it is the generalization of normal Fourier, classical Fourier transform. To illustrate that fractional Fourier transform, in this figure, we can see that the x-axis is the time domain and y-axis is the frequency domain. And here is the signal and it is the undesired noise. This signal and undesired noise can be overlapped in time domain and frequency domain. And then it is very difficult to remove the noise from the signal. So in those cases, the signal will be rotated into any angles in between the time and frequency domains. That is called the fractional Fourier domain or fractional Fourier transform. Here, when the signal is rotated into time frequency domain, then it is the energies of the overlaps of the signals and the noise can be divided. So the FRFT definition and properties, this is the definition of the fractional Fourier transform, where P is the order of the fractional Fourier transform and BP is the kernel of the fractional Fourier transform. Coming to the properties, it is a linear and unitary transform. And here, if the order is 1, the fractional Fourier transform comes to the normal classical Fourier transform. And the orders of the fractional Fourier transform is additive, and the indexes can be additive in nature. And if the order is minus P, then the fractional Fourier transform is called the inverse of the fractional Fourier transform. So this fractional Fourier transform can be used as the time frequency domain analysis. Let us see how it works as time frequency domain analysis. So here is the signal, which this is the desired signal and this is the noise signal. A normal specific filter cannot be applied on this here. So the signal is rotated in time frequency plane and into some angle. Then a specific filter can be applied to allow only the passband of this signal, and thus we can eliminate completely the noise signal. So this is the desired signal in fractional Fourier transform domain. To get our original signal, the signal has to be rotated back to its original angle. So this is the basic principle of the fractional Fourier transform. So coming to this implementation in Matlab, it follows some of the digital techniques like chirp multiplication, chirp convolution, chirp post multiplication, sampling. So this is the basic diagram or block diagram of our proposed method. Here, the input signal x of n is first transformed into a fractional Fourier transform domain using FRFT, and the noise reference signal is also transformed into FRFT domain using FRFT implementation. So XP of n is the FRFT transformed input signal, and DP of n is the FRFT transformed noise reference signal. And an adaptive algorithm is used to model the weights of the digital filter, which is using in this adaptive noise cancellation setup. So this is the output, and this is the error, which controls the weights of the input, weights of the digital filter, and the output here is in FRFT domain. So to get back in time domain, again IFRFT, inverse fractional Fourier transform, is applied here. So for adaptive algorithms, we use two types of algorithms. One is least mean squares fractional Fourier transform, and normalized least mean squares fractional Fourier transform algorithms. So these are the output equation and the error equation of the linear mean square adaptive filter, and this is the weight updation rule of the linear mean square adaptive filter. And coming to the normalized least mean square algorithm, the error output and the output equations, weight updations will be the same for NLMS and LMS FRFT, but coming to this mu LMS, means step size of this LMS algorithm will be modified using this equation. So different fractional orders will be studied for different MSCs, and here the FRFT of 0.5 gives us best result. So that is used throughout this implementation of this algorithm. So these are the results of the FRFT based adaptive noise cancellation, which was proposed. And this is the time domain waveforms. This is the input signal and noisy signal, error output and noise estimation. This is the output of the signal, which is enhanced using time domain adaptation, and this is the output of the signal, which is enhanced using frequency domain adaptation, and this is the output of the signal, which is enhanced using fractional Fourier transform based adaptive noise cancellation. So here we can see clearly that this output resembles very close to this input original signal, even the noise removed when compared to this time domain and frequency domain adaptation techniques. So these are the simulated AE signals. The study is carried out on the simulated AE signals. Now to coming to the real signals, this is the signal recorded using the drilling test on composite materials, and this is the original signal, and this is the signal added by the noise, and this is the signal enhanced by the time domain adaptation technique, and the signal enhanced by the frequency domain adaptation technique, and this is the enhanced signal using proposed fractional Fourier transform domain adaptation technique. We can also see that this signal is much better when compared to this frequency and time domain adaptation techniques, and it gives the information content related to the original signal. So to see the Monte Carlo simulations, how the performance of the algorithms in the Monte Carlo numbers of iterations, MSE, here the MSE is minimum for fractional Fourier transform domain adaptation when compared to the time domain and frequency domain adaptations for number of iterations considered or 1000. And this is the quantitative measure mean square error in dB considered, and a comparison of this graph shows the comparison for different types of adaptations, time domain, frequency domain, and fractional Fourier transform domain, and for the both the adaptive algorithms, least mean squares and normalized mean squares. Here we can see that NLMS performs better when compared to the least mean square algorithms in both the in all the cases, time domain, frequency domain, and the proposed fractional Fourier transform domain. And this table shows the comparison of the time domain adaptation, frequency domain adaptation, and time frequency domain called fractional Fourier transform adaptation for the adaptive filter normalized least mean squares. And it gives the comparison, the case studies are considered, different case studies are considered here. One is penciled brake test, and a test signal taken from the compression test of concrete is also considered, and a drilling tests of composite materials is also considered here. Here, these are the noisy signal values, and these are the enhanced signal values. This is the improved SNR, means the difference between the enhanced and the noisy signal. If we see the results, fractional Fourier transform gives the better improvement in SNR when compared to our time domain adaptation and frequency domain adaptation. For all the case studies, PLB, compression test, and drilling test. So this is for another adaptive algorithm, least mean square algorithm. These results are for, and here also we can observe that fractional Fourier transform based least mean square algorithm performed better when compared to time domain adaptation, frequency domain adaptation for all the 3 different case studies. In the paper based on the work has been published in Journal of Non-Destructive Evolution in 2020. Coming to the second algorithm proposed by us is a novel approach for acoustic emission signal processing based on nature-inspired antline optimization. Today, biology is technology means there many of the nature-inspired algorithms are being used for solving the real-world problems like system identification or weld monitoring, any applications, mechanical applications, or can be solved by applying nature-inspired algorithms. One of such algorithm is an antline optimization algorithm. This algorithm is developed by Dr. Mirzalili in 2015, and the basic principle is it imitates the behavior of the antlions, hunting behavior of the antlions in nature. This is the larva of the antlion. It digs a pit in the sand by moving in a circular path and throwing out the sand with its massive jaw. And it, after digging the pit, it hides behind the pit and waits until the prey to be fall into that pit. So based on this nature of this hunting behavior, the algorithm has been developed and the mathematical formulation for different behaviors and the process are being developed, and this mathematical formulation is here. Ants random walk, these are the different operators that are related to the different process of this hunting behavior. One is ants random walk, entrapment of ants in traps, and building traps, sliding ant towards antlion, catching prey and rebuilding the pit, etilism. These operators are the mathematically formulated, and using these formulations, the antlion optimization algorithm will be implemented for our solution of the optimization problem. So for any maximization or minimization of an optimization problem, an objective function is needed to be defined. And in our problem, the objective function is defined as the mean square error of the difference between the desired output and the output of our adaptive filter. So this is the flowchart for the implementation of antlion optimization algorithm. And this is the block diagram of the proposed technique. Here D of n is the noise reference signal and X of n is the input signal, and here it is a nonlinear adaptive filter, and the weights of the nonlinear adaptive filter are optimized using this antlion optimization technique. And here ALO operators are used and population of random numbers to find the best solution. And ALO has different operators such as number of antlions, parameters such as different number of antlions and maximum number of iterations, selection criteria, and boundaries of random members, W initial and W maximum. These are the parameters that are considered for the evaluation of this ALO algorithm. And for performance evaluation of this algorithm, we consider three objective measures. One is a signal noise ratio and peak signal to noise ratio and mean square error. These are the results. And we tried for different values, number of iterations, what is the best score, and for number of iterations considered 40 gives the best results, and we used it for the evaluation. And this figure shows the frequency, amplitude, and magnitude and frequency characteristics of the adaptive filter in time domain, and it is the frequency and magnitude characteristics of the adaptive filter using this antlion optimization technique. This is more linear characteristics we got using this ALO technique. And this is the spectrogram representation, and the graph shows that this is the original signal, noisy signal used by RLS algorithm, and signal enhanced using this ALO operator. And we can see that signal RLS algorithm still contains many noise residuals in this spectrogram, and RLS algorithms gives better output when compared to the input original signal. So these are the objective measures: SNR, peak signal to noise ratio, and mean square error. And for conventional recursive least square algorithm and proposed antlion optimization algorithm. For all the measures, proposed antlion optimization algorithm got best results. The highest values of SNR and PSNR gives the better results, and the least values of MSE gives the better results. So this is the results for composite drilling test, and these are the results for the concrete compression test. In all the cases, the ALO performs better when compared to the traditional RLS algorithm. So coming to the third algorithm, it is called an efficient harmonic regeneration noise reduction based acoustic emission signal detection. So this method is, the block diagram is, a noisy input signal will go to the two-step noise reduction process, and after that harmonic regeneration process, and the output will be given to this for this analysis purpose. This based on the Wiener normal classical Wiener filter is applied, then harmonic regenerations will be harmonics or will be reduced because of this overestimation of the noise signal. So to overcome that problem, harmonic regeneration algorithm is applied here. It is implemented in short-time Fourier transform domain. Input noisy frame is given to the short-time Fourier transform domain, and SNR is estimated, and harmonics are regenerated, and it's this is used to Decision direct approach. It is called the Decision direct approach to estimate the SNR, and it suffers from 1 frame delay, so that we use 1 frame delay here and 1 frame delay here, and again the signal is transformed to IIFT, and the output overlap method is used to get the output frame. So the parametric values considered for the implementation of this algorithm or frame length is 20 milliseconds, window function is Hanning, overlap is 50%, and this beta is equals to 0.9 and size of FFT is 512. These are the mathematical equations for the SNR. Mainly for this algorithm, 2 SNRs will be implemented. One is posterior SNR and prior SNR, and here TSNR represents that 2-step noise reduction, and HRNR represents that harmonic regeneration noise reduction. So these are the results, and this is the AE bus signal, which consists of 2 AE events. But when this is the result, when a normal Wiener filter is applied, due to the overestimation of the noise signal, the AE signal is also suppressed, and here the residual noise still remains in this normal conventional Wiener filter. But with this harmonic regeneration technique, the AE signal content is preserved, which is useful for the signal characterization, and the residual noise is also reduced completely. So these are the corresponding spectrograms for this time domain waveforms. So coming to the quantitative analysis, we carried out peak signal noise ratio and mean square error, and these are the results. The Wiener filter using harmonic noise reduction technique performs very well when compared to this the Wiener filter in STFT domain, short-time Fourier transform domain, for both the measures, peak signal to noise ratio and MSE. And the paper, which is based on this work, has been published in IET Electronic Letters in 2019. And the fourth algorithm is the pattern registration of AE signals based on neural network classifier. Is the basic diagram of the neural network, where X1, X2, Xn are the inputs neurons and input layers, and Y1 to YP are the output neurons or output layers, and these are the hidden layers. Where back propagation neural network is the algorithm used here, and the neural network architecture we consider for this evaluation is the number of here 2 input parameters, like 2 input features, RMS and the peak amplitude, are taken as the 2 different input features for the neural network, and the output layers are considered as 3, and the number of hidden layers are considered as 3. So this table presents different values for number of different hidden layers. If we see the accuracy for number of hidden layers, 10 is better results. So the number of hidden layers here are considered as 10 throughout the implementation. And this table presents the comparison for 5 different algorithms for this pattern recognition of acoustic emission signal. So the accuracy for artificial neural network is more when compared to the fine tree linear SVM quadratic support vector machine and k-neighborhood algorithms. And this is the validation matrix for the ANN, proposed ANN, and these are the ROC curves. So at epoch 22, we got the best result here, and this is the train validation and test MSE curves. Coming to the summary, acoustic emission testing method has been briefly discussed in this talk, and the various applications of AET and its signal processing methods are mentioned, and extensive experiments are carried out and results are compared with state-of-the-art methods. Proposed pattern recognition for tensile steel crack growth can be applied for reactor monitoring applications, and all the proposed approaches could also be deployed for some other NDT techniques, and future work would explore the deployment of proposed techniques in real-time AI systems for large-scale applications. Thank you.
Yes, thank you, Dr. Prajna. Thank you for the excellent presentation.
Thank you.
An interesting talk. Okay. I'm very sorry if I've misunderstood what you really mean. But you have used for noise reduction. You have used fractional Fourier transforms. You have used. You did not use usual Fourier transform. Could you please tell me the reason why? Why you have used especially prepared, perhaps I think, fractional one. For example,
Sorry, yes, sir. The fractional Fourier transform technique has advantage of some additive advantage when compared to the classical Fourier transform. With the order of the transform, we can better attenuate the signal. With the order of the transform, we have the some additional advantage. If the
what advantage could you, can you present? There must exist between the fractional one and non-fractional one. I think. Could you please tell me the advantage? I'm sorry.
Different transform orders have different, in different angle of rotations, the attenuation will be depend upon different angle of rotations as we see in here.
Your advantage is based on the angular frequency, you say?
Yes, sir. 1 minute.
If you say so, perhaps I think, by using the usual Fourier transformation, perhaps especially existing highly frequent part can be removed by applying usual.
In this figure, we can see that different fractional orders will give different attenuation or different MSE values. If we observe, if it is 0.0 or if we put it as 0.5, if the order is taken as 0.5 of fractional Fourier transform or 1.0 means classical Fourier transform. If in applying normal Fourier transform or classical Fourier transform, we cannot get this advantage. So with this additional advantage, we can see to which angle we can get the best results. So here 0.5 fifth order gives the best results when compared to this fractional order 1.0 means it represents the classical Fourier transform. So we have this additional advantage using this fractional Fourier transforms.
Thank you so much. By using, okay, thank you so much.
Thank you, sir. Thank you so much.
I studied. I enjoyed your talk. Thank you so much.
Thank you, sir. Thank you so much.
Presentation.
Thank you, sir. Thank you very much.
Which you did it beautifully,
Thank you, sir.
and I should congratulate you. And in your application, is coming from the institution where you come from, you have to use such highly technical method to detect the defects in your
Yes.
structures, because you don't have direct access. You can't
Yes.
go and take a metallurgical specimen to see if there's a crack or not.
Yes,
So
sir.
you have to detect it by some. This seems to be very promising.
Yes, sir.
And I have just one small question for my knowledge. You said something about fruit and fly, whatever it is. Fruit and fly detection, is it? Fruit fly optimization, what is it?
Sorry, sir. I could not hear you. Sorry, sir.
Fruit fly optimization, what is it?
Different is.
In one of your slides, you had.
Yes, sir. Yes, sir. It is. Yeah, it is also nature-inspired optimization technique. Different nature-inspired optimization technique like particle swarm optimization and this genetic algorithm, like that, one of the kind of algorithm, but I did not go through the details of the fruit fly optimization.
No, that doesn't matter. The name was very intriguing.
Yes,
Now, have you used your different methods, algorithms, and whatever for a particular defect of which you know the size and location? Did you see how effective is your method?
No, only for denoising of the signals only I used, and for source location I did not study yet, sir, and I will look into that in future.
Okay, thank you.
Thank you, sir. Thank you very much.
Our next speaker for today is Dr. Jc Umavati from Gulbarga University, India. And I request Dr. Umavati to start her presentation.
Good morning and good afternoon to everybody. First, I thank the organizers for giving me the opportunity to present my work. I hope you can view my share screen. Okay, thank you very much. My talk is on the computation of steady dissipative thermal convection boundary layer flow of coupled stress electroconductive polymer from an exponentially stretching sheet with hydrodynamic wall slip, Hall current, and ohmic gating effects. As we know very well that we have two types of fluids, Newtonian fluids and non-Newtonian fluids. So when we apply these Newtonian fluids and non-Newtonian fluids in terms of practical applications, many of the fluids like slurries, blood, and paints, those will not satisfy the Newtonian behavior. That is, stress is linearly proportional to strain. So who are working in fluid mechanics, everybody know about all these things. However, when we go for non-Newtonian fluids, like Newtonian fluids, we do not have a prescribed or precise equations wherein we can name these fluids. So what the mathematics people have done is, because of non-linearity, the relation of non-linearity between stress and strain, mathematically we can have n number of non-Newtonian fluids depending on the relation that we define its non-linearity. But when we use such nonlinear relations, our next job is whether this is suitable for any of the existing fluids. So this has been done since many years. Stokes, Errington, Kovin, Aero et al. These eminent professors have contributed a lot for the nonlinear relations, and the work is under progress regarding its comparison with real fluids. So whenever you have nonlinearity, we also consider the coupling between the particles. Not only when we consider both coupling and angular momentum, we call that as a micropolar fluid. Not considering the angular momentum, just considering the coupling of the interparticles, we call that to be a coupled stress fluid. These are the names given in the literature. There is no such any evidences, but defining these relations, these are the assumptions that we are going to consider. Interparticle forces are not central forces in a particle-particle interaction, but there is an interparticle couple as interparticle force. So under this action of couple, the fluid particles will have a tendency to rotate relative to their neighbors. So that, as I already mentioned, there are n number of non-Newtonian fluids, but particularly I have chosen coupled stress fluid for this model. I have evidence that coupled stress fluid models, we know very well that it is almost used in lubricants. The applications of coupled stress fluid models we have in biofluids, colloidal fluids, liquid crystals, and also in synthetic lubricants. To tell you that one of my paper way back published in 2005, I have demonstrated a relation between the coupled stress fluid and the blood flow in the arteries. This is the unique paper I can tell, wherein I have derived a relation between viscosity of the Newtonian fluid and viscosity of the coupled stress fluid. This is a unique relation that I have been seen in the literature. The geometry or the modulation how I have assumed is that what I'm going to do is, suppose you take a blood flowing in an artery. You know very well that coupled stresses, any non-Newtonian fluids means is nothing but suspensions. So when you are taking a very long artery and you assume the blood is flowing inside the artery, during the flow, what will happen? All the suspensions concentrate in the middle. Like we tell that WBCs, RBCs, they concentrate in the core region, and upper and lower, we treat that as a clear fluid. So I have used this model, and that core region, in the core region, I have modeled the coupled stress fluid. Upper and lower regions, we have clear viscous fluid. This has given me a very good result. And when I compared with the practical this one also regarding 20% concentration, 40% concentration, I got a very good result. This is being published in Canadian Journal of Physics in 2005. Who are interested, and as I once again stress that I'm happy that this is the unique paper which I have derived a mathematical relation between the viscosity of the coupled stress fluid and viscosity of the regular fluid. So using this coupled stress fluid, now I wanted to apply for polymers. So the motivation of this work is magnetic polymer processing involves multiple physical phenomena and requires simultaneous consideration of rheological, hydromagnetic, and thermal characteristics. So in recent years, we are also emerged with smart polymeric materials which exhibit multiple levels of intelligence and can be tuned to respond to different stimuli in the field. These complex multifunctional materials are known as electro or magnetoactive polymers and are polymer-based composites using electrical or magnetic fields with large deformation and tunable mechanical properties. So they generally comprise a soft polymer matrix with a filler of magnetic particles. So such studies are already being done. Other examples are electromagnetic shape memory polymers, integrated multifunctional shape memory, electropolymers, ferroelectropolymers, electromagnetic smart hydrogels, etc., etc. So what is here we are concentrating is the strong rheological nature of these materials requires advanced constitutive non-Newtonian models for their accurate simulations. So magnetic polymer processing involves multiple physical phenomena and requires simultaneous consideration of rheological, hydromagnetic, and thermal characteristics. So inspired by this application, I have used the coupled stress fluid to define the functional magnetic coating dynamics owing to the slippery motion, because boundary layer. So owing to the slippery motion, I have not considered no slip condition, but considered the slip velocity is also included. Since we are taking the magnetic this one, so I have also induced the Hall current, which counts for the secondary flow. Ohmic and viscous dissipations are also incorporated in the mathematical formulation. So methodology, as we know very well that Navier-Stokes equations cannot be solved in closed form, or exact analytical solutions cannot be solved. So almost all fluid mechanical problems are nonlinear, coupled, and it's partial differential. So we have to opt for any of the numerical codes. A number of numerical codes are there. Earlier, before these softwares have launched, we used to write our own codes and run the programs, but now we have built-in functions. So I have used BP4C in Matlab, and because these values cannot be compared with the analytical, so I have used one more numerical code, which we call it as Adams-Moulton two-step predictor corrector algorithm. Next, we go for the geometry. What is the geometry which we have considered for the study? One important point in this study is that normally we consider for the heat transfer either equal temperatures or unequal temperatures, that is heating and cooling. But when we talk in terms of different types of boundary conditions, among the first kind, second kind, and third kind, this third kind boundary condition, that is, we also call it as a Robin boundary condition. We also call it as a Fourier type. There are other names for convective heat transfer. This type of boundary condition is more realistic when compared to first kind and second kind, because third kind considers the surface temperature also. So in this paper, I have also considered the third type boundary condition, that is convective heat transfer. So the geometry includes, as we can see here, this is the slit. This is your leading edge. So X, Y, Z are defined in this way. This is your primary flow. Stretching is along X direction. I'm considering the exponential stretching, and secondary flow and the boundary conditions here are defined this way. External non-uniform static magnetic field B0 e to the power of x by 2L. Because of stretching, we have to consider e to the power of x by 2L also imposed perpendicular to the surface of this sheet, and B0 is the reference magnetic field. Electrical polarization voltage is neglected. Of course, in my future work, I wanted to include these electrical polarization effects also, but this is my first paper. So I have also assumed that magnetic Reynolds number is sufficiently small to neglect the magnetic induction effects. However, Hall current is considered, which generates the secondary flow. Magnetic polymer issues from a slit x equals to 0. The boundary layer coating grows with x coordinate as shown, as I have already told. Stretching is along x direction. Now, the next part is about its formulation. So the velocity is exponentially stretched and it is assumed to be in the form of u0 e to the power of x by 2n. The governing equations representing this flow, this is your equation, continuity equation, the Newton's conservation laws, and energy conservation. And these are the boundary conditions which we have considered. So lambda star dou u by dou y accounts for your convective boundary conditions. And this lambda and lambda star counts for your slip. So the methodology includes, first I'll convert u and v into stream function. As we know, it is a two-dimensional, partial, non-linear. It's very difficult. So what we are going to do is I reduce u, v, two-dimensional into one dimension, that is stream function. So of course, it is two-dimensional flow only along u and w. So we can take stream function. So as people who are working in fluid mechanics, these type of problems, first we convert into stream function, then go for the similarity transformations. You can see Crane, LJ Crane, he has given an excellent Sakya-based LJ Crane. These people have contributed a lot, and how these transformations have been considered, all these things can be detailedly studied in those monographs. So using the transformations and the non-dimensional parameters, we are reduced with equations as follows: the primary momentum, the secondary momentum, and energy. Here also we have again non-linearity, higher order, coupled. So what we are going to do is the well-known shooting method, that is Runge-Kutta shooting method. Runge-Kutta shooting method, which we study in our master's degree, the procedure is we have to convert. See, for example, of coupled stresses, we have fourth order. It is fourth order differential equation and non-linear, both for primary, secondary, and in the energy equation. So what we are going to apply the procedure is we reduce the higher order differential equations into first order differential equations. So assume f to be y1, f dash to be y2, f2 dash to be y3. So using like this, going for velocity and then temperature, taking these transformations, we reduce the nonlinear equations into first order ordinary differential equations. So along with the boundary conditions also, you can reduce into the corresponding conditions. Just feed these equations in your Matlab, run the program. You will get the results. So during running, you must also check for the convergences. After all, it again reduces it into the convergency criteria and also shooting. At what point it converges? It comes when you run the program. So those things are mandatory. I'm not going to explain in detail. So in order to justify whether these solutions are correct or not, as I already told, we cannot compare with the analytical solutions. So what I have done is I have chosen one more numerical method, which is predictor. Matlab quadrature numerical solutions, which we are going to compare with the Adams-Moulton. Validation with Adams-Moulton two-step predictor corrector scheme. So for this, again, the function which I have assumed is f dash with f, g with capital G, theta with capital H, and included nu to be the general function. So these are your initial guesses. F naught, G naught, H naught are my initial guesses. The predictors are then specified and thereafter the correctors are being included. So this is your two-step predictor relations for the 4 variables with the stepping distance is high. So this can be altered when you run the program depending on your convergency, how many decimal places you want the convergency. So I have considered 6 decimal places. So the corresponding two-step corrector formula is provided by equations 32 to 34. This is about the numerical procedures. Next, we go for the results. What I have done is surveying these two references, 65 and 66. The non-dimensional parameter values I have chosen to be coupled stress parameter to be 0.5, Hartmann number or Stuart number to be 0.5, boundary layer thickness 0.3, then the Hall current parameter to be 0.2, lambda, which is a slip parameter 0.3, Eckert 0.2, Prandtl 1, and Reynolds to be 0.2. Why particularly I have chosen these values? Because it relates realistic magnetic polymers and thermal characteristics. So this is the reason why I have chosen these values. Of course, because these are all non-dimensional parameters, we are free to choose any number, but in particular, surveying the literature, these values fit in perfectly for the realistic magnetic polymers. Now, going for the nature, how each parameter affects the flow field. Here, the circles are the values obtained by predictor corrector, and the regular lines are obtained by Matlab. So we can see that we have a very beautiful agreement between these two. When we consider the values of coupled stress fluid 0.5 to 12, as you can see that near the slit, that is at x equals to 0, approximately to say, for example, 1.2, the primary velocity is boosted. That means it indicates that coupled stresses in the magnetic polymer accelerates the primary flow, and we obtain a thin momentum boundary layer. But after that, there is a reversal effect. That means after 1.2, it will not support. That means it attributes to the relaxation in the fluid with greater space for the rigid elements. A similar observation was also made by Stokes. Therefore, we can conclude that strong non-Newtonian behavior in terms of coupled stresses is therefore beneficial to the primary flow. Similarly, we can go for the impact of Stuart number. Stuart number is nothing but it is the ratio of Lorentzian magnetic drag to the inertial force. So even in regular fluids also, that means in Newtonian fluids also, we observe that the Hartmann number reduces the flow. Here also we are getting the similar property, that is linear Lorentzian drag force inhibits momentum development and leads to a thinning in momentum boundary layer thickness, and this nature is uniform up to the any and becomes constant. Next, about the mixed convection parameter. You know very well that mixed convection parameter is a buoyancy parameter. So it also helps to accelerate the flow. So reveals the increment of mixed induces a strong acceleration in the primary flow. Suppose if you consider delta to be 0, it counts for your forced flow. So you can here observe that when delta is 0, that is, this is for the forced convection, and now buoyancy will come into effect, that is for mixed convection, that is free convection also. So 0.1, 0.2, 0.3, it also accelerates the primary flow. So buoyancy, as you know very well, that buoyancy is nothing but the ratio of buoyancy forces to viscous forces. So naturally increasing buoyancy will boost the velocity. So with stronger mixed convection effect, thermal buoyancy forces are amplified, which energizes the flow and reduces the hydrodynamic boundary layer thickness. Now going for what is the impact of Hall parameter. Here we can see that it's a contrast to the Stureth. That means it will not accelerate, but it reduces. Elevation in the Hall parameter accelerates the primary flow, and this response is sustained throughout the boundary layer. So momentum will be boosted with stronger Hall parameter via the cross flow, because it is a secondary flow, as I told, cross flow, which will reduce the momentum boundary layer thickness. The Hall parameter therefore generates the opposite effect to the Lorentzian magnetic drag force, which is associated with damping in the primary flow. So this is very important concept, because when you have two contrary what I can say forces, that is, one is Hall parameter, which is not allowing, and another one is the Stureth parameter, which allows. So when you have both opposing forces, it will be easy for us to control the flow, controlling these two parameters. If we want more, go for capital M, that is Stureth number, more number. If you want less, reduce that. It is a very good what I can say forces which we can control and get the required flow. So engineers therefore have the dual mechanism here, both magnetic and Hall parameter, to generate both deacceleration and acceleration. So depending on our requirement, we can deaccelerate or we can accelerate. Next, the impact of slip effect. So when there is no slip, that is when lambda is 0. Normally, when we have slip effects, it's more generalized concept when you compare practically. There is a strong boost in the primary velocity, as you can see. Again here, near the slit, you have a converse effect. The molecular slip in the vicinity of the boundary clearly aids in momentum development. However, further into the boundary layer, this effect decays, so vanishes in the Free stream. This simple model, however, does capture the non-adherence reported in polymeric boundary layer flows. So this concept, no slip condition, is also equally important, because when we are going to stretch, how much is the adherence and how much is the non-adherence on the plate is very important concept. And regarding the thermal properties, so we have Eckert number and Prandtl number. So higher Prandtl number decrement the primary velocity. As you know, Prandtl number is the ratio of momentum diffusion to thermal diffusion. So increasing, going for large values of Prandtl number, you have decrement in the primary velocity. So magnetic polymers have generally much lower Prandtl numbers when compared to the conventional polymers, owing to the presence of metallic magnetic particles. This is well-known result. So the overall effect is to inhibit momentum diffusion with greater Prandtl number and induce a thinner momentum boundary layer thickness. So if you go for lower values of Prandtl number, you will get thinner momentum boundary layer thickness. Similar effect is observed for Eckert number. So Eckert number is here, the dissipation effect is simulated both in the classical viscous heating and also ohmic dissipation. I have considered even the ohmic dissipation also. So the magnetic polymer experiences molecular relaxation and greater dissipation effects, and via elastic forces, this encourages the momentum diffusion, leading to thinner hydrodynamic boundary layer thickness. Actually, there are results which I have considered all these effects on secondary flow also, but graphically I am not displaying due to shortage of time. Now next, I will go even for temperature also I have drawn. but those things I will just put it in the conclusion part. I have only considered for the presentation the primary velocity. Similar results are also extracted for secondary velocity and thermal energy. Next, we go for the skin friction, which is also a very important physical concept. Capital M versus small m, Hartmann number and Hall parameter. Secondary skin friction, primary skin friction, secondary skin friction, and also Nusselt values. So these are the conclusions drawn. So we have considered electromagnetic polymer coating flow on a horizontal substrate, viscous magnetohydrodynamic non-Newtonian boundary layer flow of an incompressible, electrically conducting polar, electroconductive polymer from an exponentially stretching sheet. So owing to the slippery, we have also included the slip velocity. Secondary flow is induced due to the Hall current. Ohmic and viscous dissipations are also incorporated. Boundary layer equations are reduced to nonlinear coupled and then solved numerically adopting shooting, and then also using predictor connector. So the simulations have shown that increasing the magnetic interaction number reduces the primary skin friction. It strongly depletes secondary skin friction, but also Nusselt. Increasing Hall parameter elevates both primary and secondary and induces a boost in Nusselt number. Temperatures are boosted with Eckert, whereas they are significantly suppressed with Hall parameter. Temperatures are also reduced with large Prandtl number, but slightly increased with higher values of generalized slip parameter. Increasing the magnetic interaction number, there is a substantial elevation in ohmic heating effect and an associated increase in temperature and thermal boundary layer thickness. With an increment in mixed convection parameter and coupled stress parameter, there is a marked reduction in temperature. Eckert number elevates both primary and secondary velocities, whereas Prandtl number deaccelerates both primary and secondary flow. Higher hydrodynamic slip velocity initially boosts the primary, but thereafter induces a decrement. But we observe a consistent elevation in secondary velocity, increasing the slip parameter. And the impact of Hall parameter accelerates the secondary flow, but the acceleration for secondary flow is high when compared with the primary flow. Increasing the magnetic interaction number deaccelerates the primary flow up to a certain distance, and stronger transverse magnetic field and significant backflow is mobilized in the boundary layer regime. Again, elevation in mixed convection accelerates both the primary and secondary flows. Higher values of coupled stress parameter initially accelerates the primary flow near the slit, whereas deeper into the boundary layer transverse to the wall, it induces a deacceleration into the free stream. Secondary flow is, however, consistently deaccelerated throughout the boundary layer with stronger non-Newtonian coupled stress effects. So the present study has shown both Maple and Adams predictor excellent agreement, and these results are useful for simulating magnetic functional polymer coating flows. The future work is extended considering even the time-dependent effects, which will be continued in future. Thank you very much. Hello. Hello.
Hello?
Hello.
May I have some question, okay?
Yeah, please, sir, please.
Okay, okay.
Yes.
Thank you so much for your interesting talk. Perhaps you have discussed the problem with respect to the thermal convection, of course. But I think it seems to be so important for us to the boundary of the streamline flow and the turbulent flow. So perhaps I think so. Perhaps Reynolds number may play so important role for classifying between between two flows. Could you please tell me your opinion about this question? Okay.
Yes, sir. See, my work is not for turbulent. It is for laminar flow.
Laminar flow. Okay.
It is for laminar flow. And the Reynolds number, I have chosen the value which is for laminar flow. Not for turbulent. It's only streamline. Streamline function.
I'm sorry to say that almost all, no, sorry, all flow cannot be laminar flow.
Yes, I
Sorry
agree.
about this problem. I'm so sorry.
Yes, I agree. But when you go for turbulent flows, you know, turbulent flows is not because one important observation here, what I wanted to specify is,
yes,
it is a coating. My problem is related to boundary layer coating. So the chances of considering turbulency is less.
Oh, okay.
It is like a stretching. You have a plane and you are stretching the fluid like coatings. Say for example, I will tell one good example for you. Earlier, now we have pen drives. Now we have pen drives. Earlier we used to use disk. Disk we used to use. So lower level is non-magnetic. Upper layer is magnetic for the compact disk. So for boundary layer, practically we will not come into turbulent flows. You understand?
Your explanation makes my idea so clarified. Thank you so much.
Okay. There is no possibility of having turbulent flows in
thank
stretching.
you so much.
Yeah. Thank you, sir. Thank you.
The same to you, Professor.
Thank you so much, Dr. Umavati. That was really awesome presentation.
Thank you, sir.
Yes.
Okay, so good morning to everyone, and thank you to the organizer for inviting me as a speaker at this very interesting webinar. I'm Donatella Delle Cave, and I'm currently a postdoc researcher at the CNR Institute of Genetics and Biophysics in Naples, Italy. I'm going to present a work entitled Glycoval 1-CAM Drives Tumorigenicity, Sameness, and Tumor Fibrosis in Pancreatic Ductal Adenocarcinoma. Before presenting my data, I want to summarize what is known about the pancreatic cancer and which are the now available therapeutic approaches for the targeting of this very lethal disease. But first of all, let's talk about the pancreas. The pancreas is a long flat gland located behind the stomach in the upper abdomen. It contains both exocrine glands, which produce enzymes that help the body digest food, and endocrine glands, which produce hormones, including insulin and glucagon, which control sugar levels. The pancreatic cancer is a devastating, essentially incurable disease, leading to patients' death in the majority of cases. Incidence and mortality are increasing steadily, and the pancreatic cancer is predicted to become the second leading cause of cancer-related death by 2030. There are two types of pancreatic cancer, one affecting the exocrine gland, the other one affecting the endocrine gland. Regarding the treatment of pancreatic cancer, at the time of diagnosis, only the 25% of patients are surgically candidates, and even after surgical resection, only about 20% of those patients live longer than 5 years. So radiotherapy and chemotherapy are the standard treatments for the pancreatic cancer, but the targeted therapies are definitely the most promising approaches, which however still need to be improved. So currently the first line treatment against the pancreatic cancer is the gemcitabine. Gemcitabine is a synthetic nucleoside analog which works by damaging the DNA, leading cells to stop dividing. In 2011, the FOLFIRINOX regimen has been introduced for the treatment of patients with metastatic pancreatic cancer. It consists in a combination of folinic acid, a vitamin B derivative, fluorouracil, a nucleoside analog which incorporates into the DNA molecule and stops DNA synthesis, irinotecan, a topoisomerase inhibitor which prevents DNA from uncoiling and duplicating, and oxaliplatin, which inhibits DNA repair and DNA synthesis. In 2011, a pivotal work published in the New England Journal of Medicine showed that the median overall survival was 11.1 months in the FOLFIRINOX group as compared with the 6.8 months in the gemcitabine group of patients with metastatic pancreatic cancer. So FOLFIRINOX is an option for the treatment of those patients, but however, it results in a huge amount of side effects. During my postdoc, I have been interested in the study of the pancreatic ductal adenocarcinoma, also known as PDAC, which is a malignant neoplasm of the exocrine pancreas with a 5-year survival rate less than 8%. It is characterized by strong desmoplastic response impeding drug delivery and pronounced resistance of PDAC cells to chemotherapy. The lack of early symptoms and the reliable imaging methods are the principal reasons why it is diagnosed at an advanced stage, and the principal risk factors associated with the development of this disease are smoking, alcohol consumption, diabetes, and chronic pancreatitis. The PDAC originates from the pancreatic interplethora neoplasia, also known as PANIN, in which each steps in the development from normal pancreas to low-grade, high-grade PANIN up to the invasive PDAC are characterized by specific genetic alterations and by increasing desmoplasia, which consists in the accumulation of dense fibrotic stroma. The earliest mutation detected in 99% of patients is in the KRAS gene, which is a key regulator of tumor growth. It is followed by mutation in the CDKN2A and TP53, which are two genes which controls the cell status. The last stages of tumor progression are characterized by mutation in the TGF-beta signaling pathway, such as mutation in the SMAD4 and the TGF-beta receptors, which were found in more than 55% of patients. The PDAC tumor microenvironment is a complex ecosystem in which cellular and non-cellular components interact each other. The cellular components are the cancer-associated fibroblasts, the tumor-associated macrophages, the stellate cells, and the cancer cells, while the non-cellular components are different secreted factors such as cytokines and extracellular matrix proteins, which interact each other in order to support the extremely hypoxic immunosuppressive PDAC tumor microenvironment. It has been demonstrated that the cancer stem cells are the driving force behind tumor progression. They are subpopulation of tumor cells which retains the ability of self-renewal, so they have an infinity proliferative potential. They also show a tumorigenic potential, able to recapitulate the tumor heterogeneity. They also have a metastatic capacity and are highly resistant to therapy, chemotherapy, and radiation. Nowadays, there are different specific cancer stem cells markers, such as CD133 and CD44, but much more about the cancer stem cells biology still needs to be understood. It has been also demonstrated that the TGF-beta signaling is the most important signaling pathway supporting the cancer stem cells niche within the PDAC tumor microenvironment. And it has been also reported that the pancreatic stellate cells are the principal source of TGF-beta1 within the PDAC tumor microenvironment. So my study is principally focused on the analysis of the tumor stroma crosstalk mediated by the TGF-beta1. In particular, I have studied and characterized the cancer stem cell biology. I have defined the involvement of the TGF-beta during the tumor stroma crosstalk. And I have demonstrated that the blocking the TGF-beta signaling in the stromal cells will reduce tumor formation. First of all, by interrogating a different gene expression profiling data set, I found that the L1CAM gene was expressed at the low levels in PDAC cells with respect to normal pancreas. Moreover, by immunohistochemistry, I found that the majority of PDAC biopsies have reduced L1CAM expression levels with respect to normal pancreas. And finally, by interrogating the TCGA dataset, I found that the patients with the high levels of L1CAM survive longer with respect to those with the low levels. So altogether, this data suggests that L1CAM is a good prognosis factor in PDAC patients. Briefly, L1CAM is the L1 cell adhesion molecule. So it's a transmembrane glycoprotein originally discovered in the nervous system based on its important function for axis guidance, neuronal migration, and neuron-neuron adhesion. It has been demonstrated that the majority of human cancer have expressed high levels of L1CAM, but our preliminary data suggests a completely different scenario in PDAC tumors. In order to analyze the role of L1CAM in PDAC tumors, in order to characterize its relation with the cancer stem cells phenotype, first of all, I sorted the PDAC cells for the L1 low, L1 high content, and I analyzed in the sorted population the levels of the cancer stem cells markers. So in my study, I used two PDAC cell lines, the L3.6PL and the PANC1, and different patients-derived xenograft cells, such as the 215, the 354. And I found that the patients with the cells with the low levels of L1CAM expressed the high levels of the cancer stem cells markers, such as SOX2, CD44, and CD133. In order to analyze if the L1 low cells could exhibit the intrinsic properties of the cancer stem cells, I analyzed their ability to grow in ultra-low condition in order to form spheroids. And I found that the L1 low cells were able to form more spheroids respect to the L1 high. In order to analyze their ability to self-renewal, that, as I said at the beginning, is a crucial characteristic of the cancer stem cells, I sorted those cells and put them again in culture for the other 7 days. And I found that also in the second generation, the L1 low cells were able to form more spheres respect to the L1 high. In order to analyze the tumorigenic potential of the sorted cells, I analyzed their ability to form organoid-like structure in matrigel. And I found that L1 low cells were able to form more organoids respect to the L1 high. So altogether, this data suggests that the absence of L1CAM increases factors associated with the stem properties. Moreover, I found that the L1 low cells expressed high levels of the mesenchymal markers SLAG, SNAIL1, and TWIST1, and low levels of the epithelial markers DH1. Moreover, by performing a migration assay in body chamber, I found that the L1 low cells exhibited an increased migratory potential respect to the L1 high. And those cells were also more resistant to gemcitabine. This effect was probably due to the downregulation of the gemcitabine-specific transporter NT2 and CNT3, and to the upregulation of the multidrug resistance genes. So together, this data suggests that the absence of L1CAM increases migration and chemoresistance. In vivo, when subcutaneously injected immunocompromised mice, the L1 low cells were able to form earlier bigger tumors with respect to those generated by the L1 high. And the tumors generated by the L1 low cells were more similar to those found in patients. In particular, they were characterized by a huge amount of stroma, as you can see in this hematoxylin and eosin staining. So together, this data suggests that the absence of L1CAM increases the tumor growth and size. Next, I decided to genetically downregulate L1CAM by using two lentivirally shRNA constructs that I named 1 and 2. And I found that the L1 downregulated cells expressed high levels of the cancer stem cells marker. They also are able to proliferate more respect to the control cells, and we were able to form more spheres and more organoid-like structures respect to the control cells. Moreover, the downregulation of L1CAM increases the migratory potential of the tumor cells. those cells were also more mesenchymal-like and that were more resistant to chemotherapy. So together, this data suggested the absence of L1CAM increases sameness, migration, and chemoresistance. In vivo, when subcutaneously injected immunocompromised mice, the L1 downregulated cells were able to form earlier bigger tumors respect to those generated by the L1 control cells. Next, I decided to overexpress L1CAM in the tumor cells, and I found that the L1 overexpressing cells were able to proliferate, were less able to proliferate respect to control cells. They express low levels of the cancer stem cells markers, low levels of the mesenchymal markers, and high levels of the epithelial markers CDH1, and were less able to form spheres organoids-like structures respect to the control cells. So the ectopic overexpression of L1CAM reduces growth and the same properties of tumor cells. In vivo, the overexpression of L1CAM causes a significant delay in tumor formation, and the tumor generated by the L1 overexpressing cells were smaller respect to those generated by the control cells. So the overexpression of L1CAM in PDAC cells could counteract the tumorigenic potential of the tumor cells. Next, we hypothesized a mechanism through which the downregulation of the L1CAM may occur. As I said at the beginning, the TGF-beta1 secreted by the pancreatic stellate cells is able to support the cancer stem cells niche within the PDAC tumor microenvironment. So our hypothesis was that the TGF-beta1 secreted by the stellate cells was able to reduce the L1 expression in PDAC cells, leading to a more stem-like phenotype. To test our hypothesis, we interrogated the GSA gene expression profile dataset, and we found that the TGF-beta1 was expressed at high levels in PDAC cells respect to normal pancreas, and its expression negatively correlates to L1CAM. Next, we performed an in vitro treatment with the recombinant TGF-beta1 in the presence or absence of the TGF-beta1 receptor inhibitor A83. And we found that the TGF-beta1 was able to reduce the L1 expression in the tumor cells, while this effect was rescued by the co-treatment with the A83. Next, we decided to analyze the paracrine effect of the TGF-beta1 secreted by the stellate cells on the tumor cells. In order to do that, we performed a conditional media experiment, and we found that the conditional media of the stellate cells was able to reduce the L1 expression in tumor cells, while this effect was completely rescued by the co-treatment with the TGF-beta1 blocking antibody. In order to analyze if the downregulation of L1CAM may be due to the TGF-beta1 secreted by the stellate cells, we decided to genetically downregulate the TGF-beta1, and we repeated again the conditional media assay. And we found that the conditional media of the stellate cells silencing the TGF-beta1 was no longer able to modulate the L1CAM expression in PDAC cells. So altogether, this data suggests that the TGF-beta1 secreted by the stellate cells regulates the L1CAM expression in the cancer stem cells. Next, we analyzed the migration, we performed the migration assay in body chamber, and we found that the stellate cells increased the migratory potential of the tumor cells, while this effect was attenuated when the stellate cells were silenced in the TGF-beta1. Next, we performed the chemoresistance assay by co-culturing the PDAC cells with the stellate cells in the presence of gemcitabine. And we found that the stellate cells increase chemoresistance in PDAC cells, but this effect was completely attenuated when the stellate cells were silenced in the TGF-beta1. And finally, we performed an in vivo experiment by conjecting the tumor cells with the stellate cells, control or assay TGF-beta1, and we found that the stellate cells increase the tumorigenic potential of the tumor cells, but this effect was completely abrogated when the stellate cells were silenced in the TGF-beta1. So finally, our working model is the following. The stellate cells were able to produce the TGF-beta1, which is also able to reduce the L1CAM expression in tumor cells, thus leading to a more cancer stem cells and aggressive phenotype. So I want to thank all the gastrointestinal cancer laboratory, especially my mentor, Dr. Enza Leonardo, all the founding, especially the ARC Foundation, and all of you for your attention. Thank you.
Thank you so much, Dr. Donatello. Thank you for your excellent presentation.
Everybody, I thank once again for giving me the opportunity. I just want to give some introduction about nanofluids and nanotechnology. What is nano? Nano is nothing but the power of smallness. So how best you can go for the smallness, that much best the definition of nano and its applications. Now coming to what is nanotechnology. Nanotechnology, for example, you can have for engineered DNA strand, buckyball, and semiconducting metal junction. You can observe here that two metals are in conjunction with these buckyballs so that you can improve the bonding. So nanotechnology is the art of science manipulating matter at the nanoscale. This is very important. Now, coming to understand what is the definition of smallness. So I just give the comparison that our globe dimension is 1.27 into 10 to the power of 7, or in terms of kilometers, 12,756 kilometers is the width of our universe. Now, suppose if I take the ball is 22 centimeters. And suppose if I take the length of the Fuller's C60 atom, it is 0.7 nanometers. I just wanted to give you the comparison of the nanoscale with the universe and with the atom. So it is 1 billion times smaller. What are its applications? For example, here we are going to take one of the application in cancer, biomedical. You know very well that nanotechnology is applicable in all the fields of our walks of life. But the important application and its improvement required is in the health issues. As you know very well that cancer treatment, earlier days, how cancer was used to be detected, what is the improvement in the technology, and now what is the technology used in the cancer treatment. So in earlier some years ago, how the cancer was detected. So detection of cancer is an important issue. Once you can detect the cancer in the early stage, there are chances of having the patient to be survived. So here detection of cancer itself is a big challenge for the doctors. So earlier, they used to have the imaging process, that is scanning or laser beams, radiation. Through that, they used to identify whether the patient is having the cancer or not. So nowadays, you have image technology. With the help of image technology, you can identify the symptoms of the cancer in the early stage. This is one of the improvements. I just want to mention here also that in India, in Bangalore, in the cancer hospital, doctors have started treating the cancer patients with the technology, what we call it as using nano powders. What they are doing is they are using the gold particles where the cells are affected or where the portion of the body is affected. They are coating that part of the body with the gold nanoparticles. And one of my colleague got this treatment and he is very good. He has recovered. So we are finding very positive results in the nanotechnology in cancer treatment. This is one of the example. And you know very well that even nanotechnology is used in drug deliveries. Drug delivery technology is nothing but when we were small, that means when we were children, way back, say for example 40 or 50 years before, what was the medicine that we used to have is, it is like common. If you have fever, if you have headache, if you have multiple, they used to give only one treatment, like anacin or navagin tablets. But as the things technology developed in medicine, so we got treatment only for headache different, only for fever different, like that. Now using nanotechnology, what is going to happen here is, it is say for example, if you take a tablet like navagin, what will happen? You will have side effects. Side effects in the sense that, suppose if you take for headache, only to reduce headache we are taking navagin, but it is going to affect other parts of the body also. But using nanotechnology, what is going to happen here is, we call that as a drug delivery. Drug delivery means that is going to deliver the antibiotics to the particular part where you have the pain, and therefore side effect is reduced. So that is drug delivery. We call that as a drug delivery in nanotechnology. That is also one of the application with regards to biomedicine. You can also have this type of technology in agriculture. What is that? So you have a new nanotech based tools and equipments which will help you increase the efficiency and overcome challenges faced by the agricultural industry. Some of these challenges include increasing threats to agricultural production and risks of plant related diseases. So we have the growth rate reduced because of the diseases, plant diseases. So suppose if the plant is affected, what the usual treatment for the plants is, we are going to spray the medicine. So when we spray the medicine, the part which is not affected also gets the spray. That means it gets affected with the chemicals. So and it reduces the yield also. So this nanotechnology, what it is going to, though we are going to spray, but the chemical will release only to the part where it is affected, so that other portion of the plant does not get reaction of the chemicals. So this is also a drug delivery, but in agriculture. Similarly, we have pesticides we call that as encapsulated in nanoparticles. So these only release pesticides in an insect's stomach, which minimizes the contamination. Suppose if you have insects eating the plants, So what these pesticides will do is, these pesticides will enter into the stomach of the insects. There it gets released, the medicine, and the insects will die. So this is also one of the drug delivery used in crops. So there is also, say for example, you have a very good agriculture, and each plant has its own thermal resistance. That means what I want to say here is, suppose if you have a plant which cannot resist the more heat. So if you place nanosensors in your field, it will inform you that the temperature of the plant is grown, so that you can take some precautionary measures to reduce the temperature or the environmental temperature there, like spraying water or any of the other technologies that we use in agriculture, which we call it as nanosensors. So if the plant is getting some problem, so nanosensors will indicate you, and you can take care of your plants, and you can get a very good yield. And also it will tell the water, how much water is required for the plant. So water is also not wasted, and it is not all less, because you are exactly getting the information how much water it is required. So this is used in agriculture, nanotechnology, and also in space suits. You know very well that when we enter into a different world where we do not know what is there, what type of chemicals are there, what is the environmental temperature. There are a lot of, because unknown is a chaos. So we should be very careful. So earlier we used to have space suits. Now using nanotechnology, what the improvement in the space suit is, you will have two types of space suits. One is the usual space suit, and the second is the nano space suit. What this nano space suit, it will take issues of tears or ruptures and fix them before they harm the astronaut. So here also we have application of nanotechnology in spacesuits. Also you can use for robots also. Now regarding home appliances, how nanotechnology is used. You know very well that all the materials have their own thermal resistance. For example, you have a refrigerator. Our present refrigerator works in a uniform temperature. That means the temperature is distributed uniformly to all the ingredients that we keep inside the fridge. Suppose you have a fruit, that resistance is different from some vegetables. So in order to protect the temperature of the gradients, we can use what we call it as furniture fridge cores and cool food nano robotic bio gel. What we are going to do is, you take a bowl made up of a nanotechnology and keep inside it. What this bowl will do is, it will give the temperature how much is required for that gradient, not more than that or not less than that, so that you can improve the ingredients and proteins of your food. Next, we have the application with respect to what you know very well, that how best the technology has developed in electronics department, electronics area. So we have Bluetooths. So here, when we keep something inside our ears, so here it will take care of the volume control, and it will not the ears will not be, that eardrum, those things will not be corrupted soon. So these are all mobile devices. So give us new types of services like never before. That is, how much is required, it will give only that much. So controlling is there with the help of nanotechnology. Then It's a beautiful analysis. This example, I really enjoyed it. You can see what is the shape of this one. You know, in nature, the fastest flowing mud, fast like butterfly. Butterfly flows very fast. That means connectivity. So all these days, even in computers or wherever, in almost all the electronic devices, we use chips in the form of a rectangular shape. Is it not? So, but using the shape of the butterfly, the communication is fast. So, mimicking the microscopic structures in the wings of a butterfly, an international research team has developed a device smaller than the width of a human hair. Yesterday, one of the professor was giving about the application of this concrete, this one. He was telling the thickness is less than the hair. So that will give you the strong bonding, and also the communication is very fast. So they have used, instead of the rectangular shape, they have used the shape of the butterfly and in optical communication, and they came out with a good result that instead of using the rectangular shape, if you use the butterfly shape, the communication is faster and more secure also. So nanotechnology, they're mimicking the nature and also adopting in the communication technology. Now, in the near future, we also have humanoid shaped nano robots. So machines, robots are nothing but machines. Nowadays, we are seeing in Japan, in Malaysia, in the hotels, we are having man-shaped robots. Even because of COVID, they have robots similar to human, this one, but also the supply for the food for the patients using human-shaped nano robots. Even in airports, we are seeing human-shaped nano robots to spray the COVID caretaking systems. So nanotechnology is also used in human-shaped nano robots. Sorry for the disturbance. So just these are few of the applications which I have given, but you can also go for a lot of applications. We also like connect our nanotechnology to the feathers of the peacock, the colors. So even the stigma of your lizards. So like this, these are we have already in nature nano, but it's difficult for us to prepare manually such small particles. We see in nature. Say for example, you take the feather of a peacock. Is it possible for us to prepare such a small size hair of the peacock? It's highly impossible. So that is the challenge. That is the challenge that we are facing in nanotechnology. How small it is possible for you to go, that much strong the technology will be. Even we tell we are going to add some nanoparticles, but what is the preparation for the such powder type particles? It's highly difficult. We tell gold particles, we tell silver particles, we tell aluminum particles, but how best we can crush it? That is the challenge. It's a challenge that the world is facing. So now let us go for some of the problems. This is only a little bit glimpses and introduction about the nanotechnology and nanofluids. Now coming about me, I'm a mathematics teacher, so I go for nanofluids and application of nanofluids. So what is a nanofluid? Actually, we feel that nanofluids and nanotechnology is a very recent. No, it's not. 1930 itself, Maxwell started this concept. what is the nano concept, nanofluids concept? Nanofluids concept is nothing but you have a fluid. For that fluid, we externally add the nano powders, so that that nano powder should not clog or settle down. That should be the care you should take care while preparing the nanofluids. But this concept Maxwell has already started, but he could not succeed because the nanoparticles, he was not he did not thought about the nanoscale. He just took the material like carbon and added with the base fluid, but he got experimental problems because of the heavy carbon. This one, they used to go and settle down, so he could not proceed. So next they started how to avoid the settling of the nanoparticles. So that's what the nanoparticles should be like suspensions. It should not settle down, or it should create a clogging. Like what I can say, what are suspensions means, take for example our blood only. In our blood we have suspensions like RBCs, WBCs. So blood will flow easily though it has suspension. You understand, these are naturally having properties of nanofluids. I don't say that blood is a nanofluid. I'm just there is a lot of difference between preparing nanofluids and having suspensions naturally. Just I'm giving you the comparison. How we have to prepare nanofluid means it should suspend, it should not settle down. So conventional heat transfer fluids such as water, ethylene glycol mixture, engine oil have limited heat transfer. The purpose of using nanofluids is I need to control my heat transfer. It's not that if I use nanofluid, heat transfer will be high. You can also control for cooling also. You can also decrease the heat transfer. So thermal, because the thermal, normally the thermal conductivity will increase, naturally transfer of heat will be more. So therefore there is a strong need to develop advanced heat transfer fluids with substantially higher conductivities to enhance thermal characteristics. So nanofluids serve as a solution to these problems. Small particles stay suspended much longer than the larger particles. The presence of the nanoparticles in the fluids increases appreciably the effective thermal conductivity and viscosity of the base fluid, and consequently enhances the heat transfer characteristics. So thus, nanofluids may be used in various applications, which include electronic cooling, vehicle cooling, transformer, and also coolant for nuclear reactors. When I attended one of the conferences in Poland, one of the professors from Malaysia, he created a laptop wherein he used gold instead of carbon in the chips, and he got very good result that the computation was very fast when you compare with the normal laptops. But of course, the cost was very high. But people are working on this because in computers we need cooling, not heating for the chips. So you can also use nanofluids for cooling purposes, not only for heating purposes. It depends on our requirements. But people have the concept that using nano, we can only increase the heat. No, it's not that way. Okay. So I will switch over to different my PPT. Just a moment.
Thank you.
Hello.
Yes,
Hello.
Yes, we can hear you. Continue.
View this PPT. Fine. Now, after this introduction, I just wanted to give you a particular example of using nano fluids in ground holes, borehole heat exchangers. So what is a borehole heat exchanger? Actually, this we have studied theoretically, but we compare with our experimental results also. So before starting this, I just wanted to give a brief introduction about what is borehole heat exchangers. This is also one of the technique to have energy. Here, renewable energy sources, I will just give you a bit of history for the present percentage, how much is the TPS is used in the world. So renewable energy represent an alternative to meet global energy demand and at the same time to prevent occurrence of irreversible Earth's climate change. So in 2013, world total primary energy supply, that we call it as TPES, was 13.5% from the renewable energy source. So now, this can also be used for non-commercial, like one of the professor in Japan, he built his house using this technology. And it is working for throughout the year for him. He is not paying any bills for his power. So in developing countries, solid biofuels are also renewable energy source, which takes about 10.4% of the world's TPES. The second largest is the hydroelectric power, which normally we use, which provides 2.5% of the world's TPS. Geothermal, especially countries like Middle East, where we have more of solar energy. So geothermal energy will really give a very good source for the power. But people are not going in deep in this. I don't know the reasons. So geothermal, solar, wind, biogases, these are all the sources for energy supply. Geothermal is not the most, that's what I told, it is not most exploited, but every year it is growing 4 to 5%. So it is customary to divide geothermal energy into 3 areas. We divide it into, it is for our understanding regarding to its temperature of the source. It is just for our understanding. So we divide into 3 parts. One is high enthalpy, where the temperature source is above 423. You can refer Zeng's paper. The second one is the medium and low enthalpy, where the temperature is 305 to 420. You can refer Bloom for this. And the third one is the thermal baths for therapeutic and recreational aims. So here, what is the motivation of the study? As we know that in borehole heat exchangers, the base fluid, we are going to consider water as the base fluid. But now what we have in this study, what we have done is we have replaced the water with nanofluid, and we have done a very clear analysis about the energy we obtain using different types of nanofluids. I will give you the list of all the nanoparticles that we have used and what is the cost and what is the energy that we are going to get. So ground source heat pumps covers about nearly 71 of the installed thermal power. Their applications we can also use in swimming pool heating and also space free heating or cooling, agricultural drying. These are all the applications where you can use GSP. So there are proofs could represent a valid environment because we are going in the ground, so there is no issue with the environment. So this is one of the technique with environmental friendly and creating the energy. We can also use for heating and cooling systems in buildings. You know, Europe countries, how much is the difference in the temperature? They use gas, which is very costly. Life in Europe countries is not as comfortable. Rather than comfortable, I can say economy, like where the countries we have natural sunshine. So Europe countries, is also one of the difficult times to save money, because when you know very well that how much, hardly 1 month or 1.5 months you will have sun, and all other time is cold, and they use lot of gas, which is of course they have to pay money. That is different. But if you go for these types of ground, because the energy is stored when you have the sun, that can be used in the rest of the time. So drilling, of course, you have drilling costs, but once you invest, that will be permanent. That is also, and it is environmental friendly. You don't find any difficulties as it goes. The process is inside the ground. Only the thing is you have to drill the ground. So in BHEs, what we are going in this work is we replace the conventional ethanol glycol or water mixture with fluids containing nanoparticles. So nano fluids are two-phase systems. Yeah, this part I wanted to give a little bit detailed explanation. See, whatever may be the technology, but at the end of the day, we formulate into a set of equations. And with that equations, we are going to solve and apply with the physics. So, though nanotechnology and research in nanofluids is going more than 50 to 60 years, especially from 2000 onwards, we are observing in the world's research that nanofluids is working with more than 70% of the research articles are coming with nanofluids and nanotechnology. But still, people are facing a challenge how to consider the model for the nanofluids. See, we have one fluid model and two fluid model and multi-fluid models in. Whenever we define any fluid, if it is a single fluid, we use regular Newtonian fluids, and we have non-Newtonian fluids where naturally occurring. That means we fit in some of the non-linear relations between stress and strain and relate the particular fluid and name that fluid to be this. But I don't agree that it is perfectly working, but to some extent it works. This is how we are tackling with non-Newtonian fluids. Now, when you are coming with nanofluids, what we are doing with nanofluids, as I already told, we are adding nanoparticles externally. So whether we have to consider that as a two fluid model, that is, you are having fluid and particle. So that is, we have to, actually speaking, practically it is a two fluid model because we are adding externally the nanoparticles. So few researchers argue that it is a two fluid model, but few people argue that since we are adding nanoparticles, not as a individual physically affecting separate model, but we are adding nanoparticles under the conditions, under the circumstances that it is not settling or it is not clogging. That means it is homogeneous with the base fluid. So you have to treat that as a single fluid model. So Bunjorno argues that nanofluid is a two fluid model, whereas Tiwari and Das argues that it is a single fluid model. So even till today, it is a challenging. So whether to use a two fluid model or whether to use one fluid model. So still research work is going on. Do not know which is the perfect model. But papers are coming out using two fluid, I'm now working on flow problems, considering both models and observing is it there any significant difference. I'm not getting any significant results difference. Of course, mine is theoretical and it goes for non-dimensional. So maybe because of that, I'm not getting any difference whether using Bunjorno's model or using Tiwari's model. But who are hearing, this is a challenging problem. It is an unsolved problem, but no one is witnessing which model is the better model. It all depends on what type of physical problem you have at hand. So it is still a chaos how to model the nanofluids. So now for this, I have taken Tiwari-Das model. That means I am considering one fluid model only. So comprising and dispersed particles, the typical carrier media, water, organic liquids, and polymer solutions. Solid species usually represent nanoparticles of stable metals or metal oxides. You can also use metals and also use metal oxides. Who are working in nanofluids, they know all these things. So this paper, this is already published in geothermics. I did this work with one of the professors in Italy. I did this work when I was doing my postdoc. So geothermics, it is published in geothermics. So if you are wishing, you can get this paper. It's very interesting. So here, I just, because of time constraint, I'll just move on to the conclusions. A lot of physics is there. And as I already told you, this is already a published paper, but really I am happy with this paper. I just give you the pros and cons of this. What are the benefits and what are the troubles that we obtain? So here, decreasing the delta PD minimizes the energy. See, when we are drilling the ground, we get the problem of pressure. So that pressure, we got problem using is also a challenging problem for us, which is not supportive. And here, concentration, nanoparticle concentrations. It is a very big paper. It has got a lot of results. Who is interested, you can just have a look at it. I'll just go for the conclusions. And also we have calculated the cost. The details, as I told, it requires at least 2 hours for me to explain the whole paper. Just I will conclude the conclusions. So in comparison with the conventional water, we have used copper-based. Copper-based gives the better when compared to other nanoparticles. And copper oxide also. Copper oxide, I have given the percentage also, 3.5 to 3.8. But when we use copper oxide, it gives the worst. Copper gives the best, copper oxide is the worst. And silver-based nanoparticles, as I told, if you use copper, we are getting the problem with the resistance. But if you use Ag, we are getting problem with the heat transfer. What I mean to say is, if you use copper, heat transfer is more, but resistance problem is there. But when we use silver, there is no resistance problem, but the heat transfer is less. It is decreased. And like that, we have done a lot of comparisons, Cu and CuO based nanoparticles, lowest volume for it works if you have a lowest volume fraction, but when you use more volume fraction, you will have an error. Error in the sense not productive. So, and regarding your cost, again, when you use silver nanoparticles and when you use SiO2 nanoparticles, so you can see if you use silver and SiO2, the difference is from 115 to 1,140 euros. So this is also one of the things which we have to keep it in mind. So it's very difficult to come out with a conclusion that yes, this nanofluid works better. It's not like that. There are some kind of benefits and other problems also. So we have to really work out in detail. Suppose if I take silver, SiO2, I have to think over the cost. Suppose if I use copper, I have resistance problem. Suppose if I use copper oxide, heat transfer is less. So there are the things are in a mesh, but at least we have some idea of using the nanofluids. So it depends on the patents. If the patents are ready to pay good money, yeah, you can go for SiO2 and all those things. So I thank you once again for giving me today one more presentation. Okay. Thank you very much.
Thank you.
Any
Thank you
questions,
so much.
please?
Thank you so much, Dr. Umavati. Thank you so much for giving another talk. It was a pleasure having you.
Okay, it's a great pleasure to listen to your presentation, and it's a big honor to listen someone from another continent, let's say. And one of my field of research is related to your topic mostly, because we know, as it's so important topic nowadays, to collect information about such sources of energy. And in my country, we are implementing a lot of different standards and try to find appropriate for our climate, country climate, renewable sources. So I'm interested in any chance of cooperation with you on this topic, finding any solutions that could be great for our country as well. And maybe we could cooperate within the international scientific project.
Yes, Professor. I'm honored.
Thank you very much. So maybe we will exchange by emails over here, and later we can continue our discussion on emails. Yeah.
Okay. Okay. Thank you very much.
So please to send me your email address. Okay, over here on private.
Yeah, I will put in the chat.
Great. Thank you very much.
Okay.
Dr. Hassan Koten is going to give a talk on Fluel blends in internal combustion engines. And I request Dr. Hassan to start his presentation.
Thank you so much. Hello, greetings from Turkey. I am Hassan Koten. Thank you so much for me inviting to this organization. I'm very happy to attend this event as an invited speaker. Thank you to special thanks to organizing committee. I hope this event will be beneficial, and I wish you healthy and happy times during this event and pandemic. And also, I hope this presentation will lead to further projects in different research. Dear attendees, I'm going to give brief information about me. I'm associate professor at Mechanical Engineering Department of Istanbul Medeniyet University in Turkey. We made some projects regarding the internal combustion engines. We developed first full geometry engine design for TÜBİTAK in Turkey, the Scientific and Technological Research Council. During in my master and PhD, we worked, and also I worked as a visiting scholar at Ohio State University Center for Automotive Research. And also for domestic electric vehicle design project, we worked in 2017. And then I attended the CEDP group at Brunel University as a postdoctorate researcher. We attended a lot of events, and also still I'm in the Mechanical Engineering Department of Istanbul Medeniyet University in Turkey. Okay, dear attendees, today I want to give some cases, about 11 cases about the internal combustion engine and fuel blends. Let's talk about little fuel blends and internal combustion engines. Dear attendees, you know, internal combustion engines, it is a very important part of our daily life, you know, in industrial, in transportation and agriculture. Internal combustion engines, you know, works by receiving the energy from combustion of fossil fuel. And the fossil fuel, there are the non-renewable source of energy, actually. They are adapted drastically presently, so their prices, they are hiking day to day, and the exhaust emission emitted by internal combustion engine affected environment. So purely our greenhouse gases and origin global warming. You know, most internal combustion engines obtain their energy from the combustion of hydrocarbon fuel, generally with air, which converts chemical energy of the fuel to internal energy in the gases within the combustion chamber. There are many thousands of different hydrocarbon fuel components, you know, which consist mainly of hydrogen and carbon, but may also contain sometimes oxygen, such as alcohols, nitrogen, and also sulfur sometimes. The maximum amount of chemical energy that can be released, called as heat, from the fuel, it is when it reacts, combusts with a stoichiometric amount of oxygen. Sometimes, you know, stoichiometric oxygen, it is called as a theoretical oxygen. It is just enough to convert all carbon in the fuel to carbon dioxide and all hydrogen. Dear attendees, even when the flow of air and the fuel into an engine is controlled exactly at stoichiometric conditions, combustion will not be perfect, and components other than carbon dioxide, water vapor, and other components found in the exhaust products, especially. One major reason for this is extremely short time available for each engine cycle, which often means that less than complete mixing of the air and fuel is obtained. Before fuel blend, I'm going to give some info about this application for the attendees and listener. You know, some fuel molecules don't find an oxygen molecule to react with, and small quantities of both fuel and oxygen end up in the exhaust. If you look at the gasoline engine, for example, spark ignition engines have a combustion efficiency in the range of 95% to 98% for lean mixture, and lower value for rich mixture, where there is not enough air to react all the fuel. Combustion is a combustion efficiency. If you look at the diesel engine, dear attendees, we can say for the completion ignition engines, they operate lean overall and typically have combustion efficiency over 98% combustion efficiency. When we look at the different fuel, other fuels attempt to use many other types of fuel have been tried throughout the history of internal combustion engine often. And this was done out of the necessity or to promote financial gain by some group, you know, by some research center. At the present, number of biomass fuels, they are being evaluated mainly in Europe and in Asia. These include completion ignition fuel oil made from wood, barley, soybean, rapeseed, and even beef tallow. Advantage of this fuel mixture generally include availability and low cost, low sulfur, and low emission, especially. As a disadvantage, we can say disadvantages include low energy content, heating value, we mentioned about the heating value, and corresponding high specific fuel consumption. If you look at the history, dear attendees, in the late 1930s and 1940s, for example, petroleum products became very scarce. And especially in special countries due to the World War II, just about gasoline products were claimed by, for example, German, and leaving no fuel for civilian automobile use. Although this was inconvenience for the civilian population, it didn't stop them from using their automobiles. Enterprising people in several countries, such as Sweden or Germany, in Turkey, developed a way to operate their automobiles using solid fuels like charcoal, wood, sometimes coal. Using technology first reached 20 years earlier, they convert their vehicles by building a combustion chamber in the trunk of the car or a small trailer pulled by the car. In this combustion chamber, the coal, sometimes wood or other solid or waste fuel, they were burned with restricted supply of oxygen air. This generated a supply of carbon monoxide, which was then parked the engine used to the fuel. Dear attendees, if you look at fuels for spark ignition and combustion ignition engines, we can say actually crude oil, was first discovered in the 19th century, and the fuel product line generated from it developed along with the development of internal combustion engine. And also it is made up almost entirely of carbon and hydrogen with some traces of other species. It varies from 83% to 87% carbon and others, generally hydrogen by weight. And the carbon and hydrogen can combine in many ways and many different molecular components. Dear listener, one test of crude oil sample identified over 25,000 different hydrocarbon components. And the crude oil mixture, which is taken from the ground, it is separated into the component products by cracking or distillation using thermal or catalytic methods at an oil refinery system. And cracking is the process of breaking large molecular components into more usable components of small molecular weight. Preferential distillation is used to separate mixture into the single components or smaller range of components. Generally, the larger the molecular weight of a component, the higher is its boiling temperature. Low boiling temperature components, smaller molecular weight, they are used, for solvent and fuels, gasoline, while high boiling temperature components with a large molecular weights, they are used for tar and also other application, asphalt, or return to the refining process for further cracking process. The component mixture of refining process is used for many products, including automobile, gasoline, diesel fuel, aircraft, gasoline, jet fuel, home heating fuel, sometimes industrial heating fuel, natural gas lubrication, and other parts. Okay, and dear attendees, when we look at the diesel fuel, we can say also for diesel fuel, sometimes fuel oil or diesel oil, it's called as like this. It is obtainable over a large range of molecular weights and physical properties. Various methods, they are used to classify it, some using numerical scales, and also some designating it for various uses. Generally speaking, the very third refining done on a sample of fuel, the lower is its molecular weight, and the lower is its viscosity, and the greater is its cost, we can say. So numerical scales usually range from 1 to 5 or 6. Sometimes it's subcategorized using alphabetic letters. Also, we can say the lowest numbers have the lowest molecular weights and lowest viscosity. These are the fuels typically used in internal combustion engines. Higher numbered fuels, they are used in residential heating units and industrial furnaces, and fuels with the large numbers, they are very viscous and can only be used in a large, massive heating units. Dear attendees, each classification has acceptable limits set on various physical properties such as viscosity, flash point, and other important properties. Pour point, cetane number, and sulfur content also. Another method of classifying diesel fuel to be used in the internal combustion engines is to designate it for its intended use. These designations include bus, truck, railroad, marine, and stationary fuel, going from lowest molecular weight to highest. Today, dear friends, I want to give 11 cases about our studies. First one, dear attendees, you see here in this slide. First one is related to methanol, ethanol, butanol, and emission characteristics in the gasoline engine. Actually, the increasing volume of motorized vehicles lead to an increase in independence of fossil fuels and increase in air pollution. The problem can be reduced by utilizing renewable alcohol fuels such as methanol, ethanol, and butanol. The high number of octane oxygen content, it is the main reason using these fuels in the internal combustion engines. This study aims to observe the exhaust emissions of some special engine in the volume of 160 ccm gasoline engine with a mixture of methanol, ethanol, and butanol. The percentage of alcohol used is 0% to 30% by volume. And test, it was carried out in different RPM. You see here, 2000, 3000, and 4000 RPM. And the results of this study show that the use of methanol, ethanol, and butanol in the fuel mixture was proven to reduce exhaust emissions. Carbon monoxide and hydrocarbon emissions decreased as the percentage of alcohol in the fuel increased. The highest reduction in carbon monoxide and hydrocarbon emissions in methanol blended fuel was 30%, respectively 94, about 95 and 83%. Meanwhile, carbon dioxide emissions, if you look at the carbon dioxide emissions, they increased by about 35% at 2000 RPM engine speed. Based on this test, the addition of the methanol to fuel can reduce exhaust emissions better than ethanol and butanol. Actually, dear friend, methanol, it is very corrosive on metals, we can say, and poor cold weather starting characteristics due to the low vapor pressure and evaporation, If you look at the alcohol-fueled engines generally have difficulty starting at temperature below, especially 10 degrees Celsius. Often, a small amount of gasoline is added to the alcohol, this blended fuel, which greatly improves cold weather starting. The need to do this, however, greatly reduce the attractiveness of alternate fuel. And the poor ignition characteristics in general, we can say. And also alcohols have almost invisible flames, which is considered dangerous when handling the fuel. Again, a small amount of gasoline removes this danger. Danger of storage tank flammability, due to the low vapor pressure, air can leak into the storage tanks and create a combustible mixture. Low flame temperature generates less nitrogen oxide, but the resulting lower exhaust temperature take longer to heat the catalytic converter to efficient operating temperature. Actually, many people find the strong odor of alcohol very offensive. Headaches and dizziness have been experienced when refueling an automobile. And also vapor lock in fuel delivery system, another problem. Methanol of all the fuel being considered as an alternate to gasoline, and also methanol is one of the more promising and has experienced major research and development area, we can say. As pure methanol and mixture of methanol and gasoline in various percentage have been extensively tested in engines and vehicles for a number of years, actually. The most common mixture, they are M85 and M10, dear friends. And the data of these tests, which include performance and emissions level, they are compared to pure gasoline, M0, and pure methanol. Some smart flexible fuel or variable fuel engines, they are capable of using a random mixture, combination of methanol and gasoline ranging from pure methanol to pure gasoline. Dear attendees, two fuel tanks, they are used in various flow rates. Two fuels can be pumped to the engine passing through the mixing chamber. Using information from the sensor, the attendees in the intake and exhaust, for example, the EM's engine management system adjusts to the proper air-fuel mixture, ignition timing, injection timing, and valve timing where possible for the fuel mixture for fuel blend being used. Fast, abrupt change in the fuel mixture combinations must be avoided to allow for these adjustments to occur smoothly. One problem with gasoline alcohol mixture as a fuel is the tendency for alcohol to combine with any water present. When this happens, the alcohol separates locally from the gasoline, resulting in non-homogeneous mixture. This causes the engine to run erratically due to the large air-fuel ratio differences between the two fuels. At least one automobile company, has been experimenting with three-fuel vehicle can use any combination of gasoline, methanol, ethanol. Also, dear attendees, methanol, if you look at the methanol fuel, it can be obtained for many sources, both fossil and renewable sources. These include coal, petroleum, natural gas, biomass, wood, landfills, and even the ocean. However, any source that requires extensive manufacturing or processing raises the price of the fuel and requires an energy input back into the overall environmental picture, but unattractive. In some part of the country, methanol fuel, especially M10, 10% of methanol and 90% of gasoline fuel. It is now sold. It is now sold at some local service stations in place gasoline. It is advisable to read sometimes small print on the fuel pump to determine the type of fuel that is being used in passenger automobiles. Dear attendees, and also emissions from an engine using M10 fuel, they are about the same as those using gasoline. Advantage and disadvantage of using this fuel is mainly 10% decrease in gasoline use. With 85 fuel, there is measurable decrease in hydrocarbon, we can say. Hydrocarbon and carbon monoxide exhaust emissions. However, there is an increase in nitrogen oxide, and a large increase in formaldehyde formation. Methanol is used some dual fuel compression ignition engines also. And also methanol by itself is not good for diesel engine fuel because of its high octane number. But if a small amount of diesel oil is used for ignition, pilot ignition, it can be used with good result. This is very attractive for the countries where methanol can often be obtained much cheaper than diesel oil. Other diesel bus engines have been converted to operate on methanol, in tests conducted in different countries. This resulted in overall reduction on harmful emissions compared with one engine operating with diesel fuel. Next slide, please. Hydrogen and hydrogen fuel mixture. Before the next slide, I want to say something about ethanol, for example. Ethanol fuel actually is a fuel it has been used as automobile fuel for many years in various regions of the world. Some countries, they are probably the leading user were in the early 1990s. 0.5 million vehicles operated on fuels that were 93% ethanol. For a number of years, gasoline or gasol has been available at service station in different countries, mostly in the Midwest of countries, corn producing states. Gasol, dear friend, is a mixture of 90% of gasoline and 10% of ethanol. As with methanol, the development of systems using mixture of gasoline and ethanol continues. Two mixture combinations that are important are E85 and also E10. E85, it is basically an alcohol fuel with 15% gasoline added to eliminate some of the problems pure alcohol. We mentioned about these problems in the beginning of our presentation, cold starting, tank flammability, etc. If you look at the E10 fuel, it reduces the use of gasoline, no modification needed to automobile engine. Flexible fuel engines, they are being tested, which can operate on any ratio of ethanol, gasoline. And also it can be made from ethylene or from fermentation of grain and sugar. You know, much of it is made from corn, sugar beet, sugar cane, and even cellulose, you know, wood and paper. We can evaluate the ethanol and methanol fuel in terms of the cost. This will be reduced if larger amount of this fuel they are used. However, very high production will create also food fuel competition, with resulting higher cost for both. Some studies also show that in different countries, crops grown for the production of ethanol consume more energy, plowing, planting, harvesting, fermenting, and delivery than what is the final product. And this defeats one major reason for using an alternate fuel. Ethanol fuel, less hydrocarbon, we can say emissions than gasoline, but more than methanol, we can summarize. Let's look at hydrogen fuels. Fuel consumption and emission comparison of conventional and hydrogen feed vehicle. Dear listeners, you know, current environmental concerns on the exhaust emissions, especially nitrogen oxide and particulate matter emissions caused by diesel engine, have led researcher to be interested in investigating vehicles with alternative power sources. Because of this reason, study vehicle models with spark ignition engine were adopted in the conducted study. Firstly, as an initial step, we used 1D quasi-dimensional code. Spark ignition engine models were created with use of some software. For cylinder engine model was created for conventional vehicle model, while a two-cylinder downsized engine was adopted as a subsystem of hybrid vehicle model. The models were based on experimental data obtained from laboratory test tub with single-cylinder engine. Subsequently, detailed engine maps on the emissions and the fuel consumption were generated with the developed artificial neural network. And the fuel also in the study, and the fuel consumption and emission data, which were gathered from an EDC and WLTC simulations, were compared for internal combustion engine and hybrid vehicle with the help of the vehicle model, which was developed by using Matlab software. Based on this result, it was concluded that there might be sufficient improvement in the fuel consumption and significant improvement in emission with use of a special case for a hybrid vehicle. Let's look at the other study, other case. Dear friend, you see here, it is about the performance and emissions of spark ignition again, spark ignition engines filled with petrol and methane. Diesel engines using compression ignition, you know, they are increasing the probability in some cities due to the increased environmental concerns. This could lead to use of low-powered spark ignition engines in hybrid electrical car. Using alternative fuels, you know, it is important for all engines, but here spark ignition engines. In this research study, performance, you can see also the link below the slide. You can click, you can read a few text from this link. In this research study, dear friend, the performance and in-cylinder pressure data, they were collected from petrol and methane fueled spark ignition engine. Theoretical model, it was then verified using experimental data. The theoretical results for methane and petrol, and they were finally compared for different engine speed. Theoretical model used a combustion model and chemical kinetics model to compare the effects of the methane and petrol on an engine performance and emissions at different engine speed. Thanks to the high knock resistance of methane, the most suitable ignition advanced value was decided for the methane fuel simulation by considering the maximum thermal efficiency to limit assumed reductions in the indicated thermal efficiency and also indicated mean effective pressure compared to previous studies. There attending slight reduction in nitrogen oxide and carbon monoxide emissions. They were observed when using methane at full load. We can summarize the advantage of natural gas as fuel include octane number of 120, you know, which makes it very good for spark ignition engine fuel. One reason for this high octane number is fast flame speed, we can say. And also engines, internal combustion engines can operate with a high compression ratio and low engine emissions, less aldehyde than with methanol mentioned before, previous slide. And also fuel is fairly abundant worldwide with much available in some countries. It can be made from coal, but this would make it more costly. If you look at the disadvantage of this fuel, as an engine fuel, dear attendees, we can say low energy density, resulting in low engine performance, and also low engine volumetric efficiency. And because it's a gaseous fuel, need for large pressurized fuel storage tank, another disadvantage can be considered. Most test vehicles have range of only about 120 miles, for example. There is some safety concern with pressurized fuel tank, another issue. Inconsistent fuel properties and refueling is slow, such as electric car, a slow process. Some very large stationary compression ignition engines operate on fuel combination of methane and diesel fuel. Natural gas contains, methane. It is the major fuel amounting to more than 90% of the total. It is supplied to the engine as a gas through a high pressure pipe. A small amount of high grade low sulfur diesel fuel is used for ignition purposes, pilot injection, The net result is very clean running engines. We can say these engines would also be good power plants for large ship, except that high pressure gas pipes, they are undesirable on ship. When we look at the historic engines in some countries in Eastern and Southern Asia, buses using natural gas as fuel have a unique fuel reservoir system. The gas is stored at about 1 atmosphere pressure in large inflatable rubber diaphragm on the roof of the bus. In Turkey also you can see with a full load of fuel, the bus is about twice the height as when it has no fuel. No fuel gauge is needed on these buses. Okay, next study related to ethanol addition. Yeah, you see effects of different levels of ethanol addition on the performance, emissions, and combustion characteristic of gasoline engine. Dear attendees, you can read these articles from this link below the slide. You can click, you can read full text. In this study, dear friend, 4-stroke, again, naturally aspirated single cylinder test engine, spark ignition engine used. It was operated with neat gasoline fuel. In cylinder pressure, performance, and emission value, they were obtained at full load and 2,400 RPM is a constant speed. Using this value, a single-dimensional theoretical model was calibrated, and also here we used special spark type pressure sensor. It was used to obtain in cylinder pressure value, above 100 bar and also about 4,000 Kelvin degree Celsius temperature about. After validation of single dimensional theoretical model obtained by the help of engine analysis software, quasi-dimensional software, different levels of ethanol addition in the range of 2.5%, 5%, 10%, and 15%, and also 20%. They were experienced in this ethanol addition into gasoline. They were analyzed and compared with neat gasoline field conditions. If you look at these results, we can say nitrogen oxide emissions. You can see here the pressure value of the test. And also we can say nitrogen oxide emissions increased with incremental amount of ethanol. And also hydrocarbon side, we can say the carbon monoxide and total hydrocarbons emissions decreased. However, they can be controlled using after-treatment systems such as three-way catalyst, you know, some special applications after engine. Okay, dear friends, you can see more details in the link you see on slide. Okay, next slide. The attendees you see here. In this case, we tried biogas in diesel engine, compressed in compressed storage tank. Dear attendees, let's talk about this case. In this study, as an alternative to conventional engines, compressed biogas, such as LNG, CNG, how we call this? This is a CBG, compressed biogas. Compressed biogas CBG fueled compression ignition engine. It was studied. Biogas is considerably economic due to the local product, you know, fuel compared to that of CNG and LPG fuels for many countries. Here you see the numerical simulation of this study, dear attendees. We said this CBG fuel, dear attendees, we can say this CBG fuel is easily found and also local product of fuel compared to the that of the CNG and LPG fuel for many countries. In addition, due to the higher octane rate, biogas is considerably adaptable for the compression ignition engines. In this issue, CBG compressed biogas diesel fueled engine, it was investigated using fuel geometry you see on this slide, and 3D computational fluid dynamics code, CFD simulations, including intake and exhaust ports. They were used in optimization process to get the optimum design parameters of the CBG diesel engine. You know, usage of compressed biogas CBG fuel in the optimized engine without any constructive change in cylinder block will considerably decrease the cost. During the engine design, also one-dimensional, quasi-dimensional code also is used. and also a three-dimensional CFD codes. Here you see the results on this slide. And also multi-objective optimization code, they were employed by coupling the codes. Dear attendees, CBG, compressed biogas, and diesel fuel, they were defined as leading reactants using user-defined code UDF in dual fuel diesel engine modeling. And CBG and diesel mass flow rate start of the pilot diesel fuel injection, compression ratio, valve timing, and engine speed. They were defined as an input variable in different engine load and evaluated about 20,000 cases to define the proper operating conditions. If you look at the result, we can say CBG engine, CBG compressed biogas diesel engine, and significantly lower nitrogen oxide emissions were emitted under dual fuel operation for all cases compared to the conventional diesel engine at all engine of load conditions. Moreover, CBG, compressed biogas diesel engine, provides superior performance in the reduction of nitrogen oxide and particulate matter. Dear attendees, you see the 3D animation of this study, CBG, compressed biogas and diesel fuel. We used here a mini software to analyze this fuel mixture in this combustion chamber. You see on the right side intake port, and left side is exhaust port. Also, you see the combustion chamber. Dear attendees, you see here on this slide the results. This is our geometry. You see our geometry. Diesel fuel, it is injected the cylinder head in injection point, and with a pilot diesel fuel, we used here pilot diesel fuel, and you see here intake port in this numerical simulation. Here we define different fuel injector on the intake port, and through this intake port, CBG fuel is delivered to the combustion chamber, and air fuel mixture in the combustion chamber, it is ignited by the pilot diesel fuel, small amount of diesel fuel. You see the cross section of the combustion chamber, and you see valve guide, intake and exhaust side, intake port, and the CBG fuel injector, and at center here on the combustion chamber cylinder head, we have another diesel injector for the pilot diesel fuel. You see the temperature and pressure results here on the right side with different cases, and also emission results here you see. Full text you can read using this link. Full text you can read the full text using this link. This was the CBG fuel, compressed biogas and diesel fuel application. Okay. Next one. Dear attendees, it is related to hydrogen usage. Hydrogen usage on combustion characteristic of spark ignition engine again. In this study, our research group, initially in a single cylinder naturally aspirated spark ignition engine, they were loaded with alternative current engine dynamometer and spark plug type engine transducer was used to obtain in cylinder pressure. The engine here, the test engine was operated with a gasoline fuel at full load and different engine speeds in the range of 3,100 to 3,450 RPM. Secondly, using obtained engine performance and emissions and cylinder pressure, you see one-dimensional engine model also was built and validated by an engine performance and engine emission analysis software, cross-dimensional software. After the validation of single one-dimensional theoretical engine model, comparison was made between the emission, performance, and combustion value of operations with pure hydrogen fuel, and such value of the operations with unleaded gasoline. The emissions of carbon monoxide, and here you see the total hydrocarbons. They were negligible with using hydrogen as fuel in gasoline engine. A dramatic increase in nitrogen oxide emissions was obtained with using hydrogen as fuel. However, by using hydrogen in lean conditions, nitrogen oxide emissions were taken under control by means of with flammability limits of hydrogen. We can say okay, next slide, please. Another hydrogen study. Here you see the effects of different level of hydrogen and LPG addition on the emissions and performance of diesel engine. You know, complying emission regulations and diesel engines damage on environment. We said they have led researchers to work on alternative fuels such as LPG and hydrogen in recent year, fuel blend and fuel mixture. Diesel engine costs, they are also increasing, especially on the increased cost of after-treatment equipment used in diesel engine. So, yeah, we used after-treatment in our car, but our main goal is keeping these emissions inside the combustion chamber, not after-treatment system. It's also known that diesel engines release nitrogen oxide and smoke emissions are highly harmful to the environment and to the living health. The effect of the emissions of LPG and hydrogen here with different energy contents from 0 to 45%. At full load and same torque, here it was 70 Newton meter. At a constant speed of 1,200 RPM. And also it is investigated this value on carbon monoxide, total hydrocarbon, nitrogen oxide, and smoke emissions. From the result obtained, there was a slight increase in brake thermal efficiency, carbon monoxide, and total hydrocarbon emissions. However, significant improvement in nitrogen oxide and smoke emissions, they have been achieved. If you look at the results, results show that using LPG and hydrogen in diesel engine, older technology, and lower cost of after treatment equipment can be used, and that nitrogen oxide and smoke emissions of diesel engine can be reduced significantly. And also, dear friends, we can say here, using a small amount of hydrogen, about 20% of total gas mixture, and LPG, liquefied petroleum gas, an important improvement can be achieved, and the harmful effects of diesel engines can be suppressed thanks to unique properties of hydrogen fuel. Okay, next one. And also you can read the full text using this link, dear attendees. Okay. Another study, it was related to techno-environmental study on reciprocating engine in internal combustion engine fired with syngas produced by gasifying different types of local coal, Turkish lignite. You know, actually, reciprocating internal combustion engines, they are well known and widely used technology. We said in our presentation, worldwide production of reciprocating internal combustion engines. It is over 200 million units per year. Syngas shows different combustion properties as compared to conventional fuels in gasoline and diesel. And therefore, conventional engines need some design modifications in order to be able to run on this gaseous fuel. Nevertheless, gas-fired reciprocating engines filled with syngas, they are available in the current market. This study investigates the performance of the system made up of gas-fired and reciprocating engines. Performance analysis of the gasifier engine system has been identified and investigated by building a simulation model. In the simulation, here you see 9.7 megawatt reciprocating engine was filled with syngas derived from 5 different low-grade local coal, Turkish lignite gasification. And first, configuration of the system is examined in the aspect of electricity generation efficiency and emissions of the gas engine. Okay, another study, another text. Your friend, one-dimensional modeling of gasoline alcohol dual-fuel combustion engine. In this study, experimental outcomes from spark ignition engine, which filled with different ethanol rates, percentage of alcohol content in the total fuel blend is varies between 1% to 20%. They are correlated with theoretical still of combustion codes for one-dimensional analysis. And also our last study, dear attendees, you see another last case, microwave assisted pilot scale and biodiesel production and engine tests also, our last study. You can read the full text using this link on the slide, dear attendees. a pilot scale microwave biodiesel reactor. It was about 60 liter. It was designed, manufactured, and utilized to produce biodiesel from sunflower, canola, and soybean oil. In addition, the engine performance and exhaust emissions of sunflower-based biodiesel and its blend with petroleum diesel, B0 in the study, I remember B5, B10, and B20, also B100 pure biodiesel. They were tested using single-cylinder direct injection diesel engine, local production, under constant speed and partial load. If you look at the results carried out under microwave radiation show that 5 minutes transesterification in the presence of 1% potassium hydroxide and 6:1 methanol to oil molar ratio. It was adequate for converting pilot scales of sunflower, canola, and soybean oil to biodiesel having over 95% ester yield and 96% over ester content. 3.5 and 5 millimeter second kinematic viscosity and about 0.9 gram per centimeter cube density value we obtained. Exhaust temperature and emissions of carbon monoxide in this study and hydrocarbons, they were reduced with increase in concentration of biodiesel in the blend, in this fuel blend, while emissions of nitrogen oxide and brake-specific fuel consumption, they were getting worse. As a result of this study, microwave technology could be adapted to pilot-scale biodiesel batch reactor. And biodiesel suitable for use in diesel engine has been manufactured more efficiently and accomplished faster than a conventional system. Okay. Dear friends, dear attendees, so our research group in Turkey, we are studying experimentally and also numerically, you see here, using some special codes, 1D and 3D simulations. So we can also use multi-objective optimization code to get proper operating conditions of the engine. Today, I summarized special 11 cases about fuel blends in internal combustion engine, dear attendees. Thank you so much for your listening and attending this event. Special thanks to the organizing committee again. And also you can attend, you can read our full text article using the link below the slide. And also you can attend our research group. Thank you so much.
Yes. Thank you. Thank you so much, Dr. Hassan. Thank you for your excellent presentation.
Thank you.
Okay. Our next speaker for today is Dr. Renata from Rzeszów University of Technology, Poland. She is going to give a talk on health and safety management at teacher work position with regard to pandemic time. I request Dr. Renata to start her presentation.
Okay. Good morning to everyone. Hello. I have a question. Do you have a possibility to see my presentation?
Yes, yes, we can see your presentation. Please continue.
Okay. My name is Renata Stasiak-Betlejewska. I am a doctor from Częstochowa University of Technology in Poland. I work at Department of Production Engineering and Safety, which is located at Faculty of Management at our university. I would like to tell you some about me. I am a teacher and scientist as well at this Faculty of Management. And I'm also a coordinator of International Erasmus Plus Academic Exchange Program. So those facts will be also important for my today topic. And I'm also supervisor of students group that was established 5 years ago. I deal with national and international projects and conferences, with organizing of lectures, seminars, workshops, and trainings for students and for companies as well. My field of research interest is connected with profile of my department. So I deal with production engineering and safety. I'm a teacher on courses like quality management, production management, and production and services management, safety management. Our department deals with quality and safety issues that are very important for industry, and we have some experience on scientific projects and workshops for companies as well. Work safety has a growing importance for companies because work safety it's not a result of regulations, but it's very important because of hazards issues at companies, not only production but services as well. There is very important issue like health insurance and workers protections. A lot of workers associate safety with rules at a workplace. They have to remember that they are responsible for own safety and safety of other workers at the companies. They have to remember that all accidents are preventable, and they have to know that there are some rules related, for example, with shortcuts and trainings on safety. Workers are aware of safety issues because they have to feel safe. It's a basic need of every human beings, and it must be fulfilled because safety is not only basic need, but it has a great influence on our satisfaction from the work. And on the right, you can see a triangle telling about relations between safety, work, and health. We know that safety has a big influence on increasing productivity, and work has relations with the safety in implementing reduction accidents at work. We have to also remember that a healthy worker It means that we have a reduction of absence at the work, and we can, this way, we can plan our future production amounts. In general, ensuring safe work performance in workplaces is legally sanctioned in Poland and other countries as well. In our country, ensuring safe work performance is related to mainly to labor code, where is written that employer is obligated to inform employees of the occupational risk associated with the performance of activities and the principles of protection against hazards in the work environment. So it's very important for employers to remember about their duties with regard to labor code, which is connected with ensuring safe work environment. Today, I will mention also some issues connected with occupational risk that is in accordance with one of our Ministry of Labor and Social Policy regulation. Means a probability of undesirable work-related events that can result in losses in the company, in the organization, in particular the occurrence of adverse health effects in employees as a result of occupational hazards occurring in the work environment or performing work. So ensuring appropriate safe work level is very important because it has a great influence on the work performance in the future. The risk assessment performed is the basis for the employer's use of work organization and creation of workplaces that protect employees against accident hazards and the effects of harmful and far harmful factors. So risk assessment is, I can say, one of the most important elements and basis for the identification and elimination by the employer, of course, of threats to the health and life of employees through the use of appropriate technologies, devices, materials, and substances that do not pose such threats. So in cases where a risk reduction in this way is impossible, the employer is obligated to apply appropriate collective protection measures and at the least to supply personal protective equipment that will create safe environment sources for the worker. And here, sorry, you can see the Polish language, but some research presented by fellows in just 5 years ago, but the statistics are almost on the same level today as well. Some statistics says that 74% of workers have a problem with the appropriate body position at the workstation. 77% of the workers sitting in inappropriate way at the desk. So there are some bad behaviors at work that create unsafe situation for workers because it can have influence for their future health. So we have to remember, for example, because statistics, that we have to have a break during the working with the computer. And why those statistics are so important and why companies should take care about satisfaction and work comfort for the workers. They have to, companies in general have to remember that satisfaction of the workers is created mostly by ergonomic conditions that create a good, safe environment for the workers. So good satisfaction of the workers is created in 95% by office environment and 92% by the work position place. So companies, they most of them, they are aware that creating a safe workplace is very important because companies are based on people work results, and it's result from their satisfaction that are under impact of the appropriate work conditions. So on average, 90% of companies' costs are connected with personal cost. So for example, some studies show that 80% of people in the last 3 years have suffered from ailments caused by an inappropriate working environment. So can you imagine that it has a great impact on the level of presence of workers' presence at the work. Some statistics say that approximately 40% of workers in Europe have never passed the workplace organization test, although 56% of them know that it is a legal obligation of their employers. So we have to remember that safe work is not only obligation of the worker, but mostly is obligatory conditions for the employer future. I mean here that ergonomic workplace is a result of law regulations like Council Directive or European Union Commission. And for example, in Poland, we have some other regulations connected with the ergonomic workplace, resulting from regulation of the Minister of Labor and Social Policy. Almost every year those regulations change because of different European standards come to our country, but also is influenced by changing different factors that create a new work conditions for workers. So for example, pandemic situation creates new regulations with regards to not only ergonomic workplace, but mostly by a time of worker working with computers. Why employers should take care about ergonomic working conditions? First of all, as we established, obligation results from provision of law, but providing comfortable working conditions has many benefits. There are some statements which are facts. Employees are more satisfied with their work and therefore more involved if they have safe work conditions. They are more effective by carrying out their work in conditions adapted to their needs. So we have to remember that people working on different work conditions has different needs, expectation, and there should be supported some different factors that could create a good work level. And what is more important, taking care of the comfort of work improves the image of the company, because good employer is a satisfied employer who has a good well organized, for example, equipment at the work, at his ergonomic area. And the ergonomic equipment of the workplace is investment that is profitable, just like a wise investment in the most important capital of the company, which are employers. The employer does not suffer financial losses due to employer illness if can be caused by poor working conditions. So we as employers, for example, should be aware of result of working in a poor working conditions, because it creates future health of our workers. And here you can find a typical pattern of the computer position for the workers that should be supplied to any worker working with the computer. There is not only about the position of the computer with regards to the body of the worker, some kind of dimensions parameters, but also we have to remember that workplace is related also to the environment, like surface of the room where is this workplace. It's a matter of the appropriate equipment, which has appropriate lighting, supportive for the working with the computer. And here we can see that the order at the workplace is very important, not only because we couldn't find anything in this place, but also important for the safety of the workers working together. In the pandemic time, it's very important not to have only a good, well-equipped workplace, but we have to be separated from others to avoid any risk of taking illness from others. As I told you at the beginning of my presentation, analysis of the risk at the workplace is one of the most important things that helps companies to avoid the future problems or costs related with the health of the workers. So here you can find basic principles of conducting an occupational risk assessment. They were used in my research that I will show you later. There's a piece of my research related to academic teachers' workplace, where I analyzed the level of the occupational risk, and I recommended some corrective and preventive actions. So the first step is identification of threats as a result of collecting the necessary information. Later, we try estimating the level of occupational risk, and recommend, on this basis, corrective and preventive actions that helps companies to avoid future risk or just decrease the risk of some hazards. It's very important that such an occupational risk assessment should be done periodically. So from time to time, and in the case of any accidents at the work, it should be done again. And information in the form of reports should be presented not only to managers of the company, but mostly to the workers to confirm the result of the reporting, and to train workers because of corrective and preventive actions. Documentation is one of the most important elements of this process because everything should be noted, identified, and should be analyzed with using different methods and using different factors of those methods. In the identification of the threats is a hazard, is very important to find the definition, and is very important to understand what does it mean. The threat is a condition of the work environment that may cause an accident or illness. So there are two types of threats resulting from the work environment, determined by physical, chemical, and biological factors. So, for example, just in an example of my work place, biological factors can be connected with a COVID, for example, resulting from the direct contact with a student. Another type of the threat is result from the way the work is performed. There are some methods of identification of those threats. It's very important to collect information on all levels in the company. So the first is recommended observation of the work environment that can be done by workers and managers as well. There is not only free observation, but observation of tasks performed at the workplace and outside it. We use some interviews with employees, free or just prepared before interview process. There should be analyzed documentation, workplace instruction procedures that can give us a lot of information about not only processes, tasks, but also conditions and equipment that is used in those processes. And finally, we need results of tests and measurements of harmful factors or chemical substances that are used in those processes. And it's very important to get also documentation on accidents at work that create the view of our point of view about the safety level at the workplace. There are some tools for obtaining information about hazards. That is element of analysis of work safety. Tool consisted of defining the goals of the task performed by the employers, determining the list of performance activities, and determining the risk associated with the performance of each activity as a result of the process. For example, there is a question: what type of accidents may occur at the workplace? What type of effort and its intensity? So, for example, let's consider a teacher, academic teacher work place. What type of accidents may occur during my task? It can have relations with working with the computer and other equipment which is in the surrounding. Though this equipment should be safe for me and for the others which share this workplace with me. So at home, for example, it is very important to have well-equipped, organized workplace that is safe not only for my body, but as we talk about the body, it's not a matter of the electricity, but also supporting appropriate lighting in the workplace, and that it can work safely. And there are some other questions connected with the whether there are any harmful, dangerous factors that can create an accident. So, for example, If we talk about work of teachers, who work at the laboratory, we have to consider the influence of chemicals or other things that could create dangerous situations at this work. And risk assessment procedure consists of interrelated steps. In Poland, we use some standards, Polish standards connected with the analysis of risk assessment. For example, this standard 18002 consists of the following activities. First step is risk analysis to gather information. As I told you before, it's very important to collect information coming from the observation of the workplace and so on. So we have to collect information related with characteristics of the work. So we mean location, performed task, characteristics of people working in this position with particular emphasis on pregnant women or other people, for example, disabled people. What is very important to create the future conditions with regard to disability, and technology that are and materials that are used during those processes. It's very important to identify activities performed and time of their performance, sources of identified threats by workers and managers as well. And we have to consider application of protective measures to analyze the level of the risk. The next step is hazard identification, which should include determination of harmful and dangerous factors present at the workplace. As I told you, for example, in the case of the teacher working at the laboratory, is very important to analyze special characteristics of those substances used at the laboratory. But in the pandemic time, we have to remember that some of our work tasks can be done at home. We cannot take our task related with the working in the laboratory to home because we have no conditions to do so. But we can conduct our lectures at home without using those substances. So the quality level of teaching is much lower, but we have to remember about supporting safe conditions. So what should be done in the laboratory should be done in this place where you can find some different information. Okay, sorry, because I've got information from one of the participants. I'm happy later I will read your questions, but first I have to finish my presentation. So in order to determine the risk that is related to the presence of harmful factors, it's necessary to establish a list of those factors and to find properties of those factors. As I told you, in our Polish regulations, we have as a attachment to regulation list of dangerous substances, for example, that should be considered in such a risk assessment. And the finally third step in this risk analysis processes is a risk assessment that involves assigning measures to the individual risk element. So we analyze the probability of an injury and the severity of an injury or deterioration of health, so consequences. However, scales are recommended, the use of which does not require extensive expert knowledge. Estimating the level of occupational risk, it means identification of undesirable consequences of the activation of threats and the probability of the occurrence. So there are 3 levels. As I told you before, it's not difficult because we use simple levels. Calling occupational risk as a small, medium, or high. We measure severity of the consequences. You can see here in this table, and with regard to probability. Okay, and we have some we have some examples of methods that help people dealing with the work and safety conditions to measure the level of occupational risk. For example, OVACO working posture analysis system, analyzing the worker's body position and strength, external strength and time of stabbing. Another method, rapid entire body assessment, is a method related to the assessment of the body of the entire body during the work time. And another connected with the one of the Polish standard method of OCRI. It's a method devoted for occupational risk during conducting work tasks which are repeatable with using hands. So finally, some my research results. Here you can see, for example, introduction to the analysis, which is focused on first job description, including workplace descriptions. So sorry for the mistake, is not academic leader, but academic teacher. The position of an academic teacher at the technical university is located on the premises of a public higher education unit, and its scientific and didactic partners as well. So if we talk about a situation without pandemic, we can say that teacher used to give, for example, lectures at her university, but sometimes we have to travel because of scientific projects, activities, or because of different international scientific academic teaching programs. So we relocate, and our work task can be done in different places, but those places should be prepared by and supported by employers early before our working tasks beginning. So these activities regulated by a great number of different law regulations relating to education, research, international academic exchange programs, and it's subject to many regulations related to the labor code and occupational health and safety rules, which are not only established for universities, but for organizations that where people are employed. It's very important to find a task and activities performed by academic teachers. So we deal with conducting courses with full-time and part-time students, Polish and foreign, in Polish and English language, in the form of exercises, lectures and seminars with using laboratories or just regular rooms for seminars. We deal also with consulting for students, which can be done at our offices. So there should be also equipped by safe working conditions. We deal also with our scientific work as a part of our research projects. So we use, except of laboratories, we are able sometimes to go outside to companies and there continue our research. So if we are going to any other unit dealing with research, for example, company, also company employers should remember about that we are out external worker, but he or she, the manager of the company, should support, should supply the appropriate, safe work and healthy conditions for us as well, even we are not the worker of this company. We deal also with the regular organizational activities of the faculty, participation in committees, exams, meetings concerning university development. So there we think about not only equipment, but supplying us a good work conditions related to our physical position. And we also evaluate students' work with using, for example, computers and other things like tools in laboratories and so on. So we have to have also safe equipment that help us to conduct our working task in an appropriate way. In this analysis, there should be a description of the workstation equipment, materials, and work equipment used at our work. So we think about mostly about computer, printer, scanner, multimedia projector, desk, and so on. And nowadays, considering pandemic time, it's a matter also supporting supporting our workplace at home as well. It's not always done prepared in a good way, because employers cannot analyze our workplace at home because of the regulations. And there is a matter also, there is a problem of processing of the personal data connected with the our presence in the internet. We use internet technologies, we use platform to give lectures and courses. So it's a matter to support not only our health and safe environment of our work, but it's also a problem of supporting healthy and safe conditions for our students as well. So we workers are also responsible for safe conditions that could be supplied for our students to give the highest level of the education as we can do during our task. And finally, you can find here, sorry in Polish, but I will translate you some important elements. You can see the piece of analysis of professional risk of academic teacher. Sorry for a moment, because, okay, now it's okay. Here you can find the characteristic of the workplace, including our tasks. So we are responsible for it, for lectures, courses working with the computer, and courses in a specialized electronics laboratories. So we have to remember about collecting information with the equipment of the workplace related with the giving lecture, for example, and working in the laboratories. So everything should be elaborated in the first chapter of such a professional hazard assessment. Later, we try to identify the threats by description of the threat, which can be harmful for the teacher. So we analyze not only tasks, but also we analyze equipment that could be a source of dangerous situation at our work. And also we have to analyze our position, a physical position. Of course, we have to remember that some situation connected with doing some task, for example, at the laboratory, cause a stressful situation. So we analyze everything, not only equipment, but body of the worker as well, which is under influence of the equipment and cause the future healthy problem with the health. So here you can find a lot of different factors related with this equipment, with the surface of workplace, with the body, with the eyes, talking elements of us, and some of the environment elements that can cause, for example, the fire in the workplace. And we analyze also elements like factor as a aggression from other people, which work with us. For example, aggression of other workers, of a student, for example, or a lack of the contact with other students during our courses. And other factors, stress, so it's connected with emotional harmful factors, biological harmful factors related with the taking a risk, being under risk of taking COVID from others. And later, with using data, we analyze not only threats, but consequences of the threats with that stable, with the level of the threat analysis. There is, for example, here, there is a big risk of negative consequences by using dangerous, for example, electrical network or equipment. And probability of these consequences is small, and we analyze also a risk. It's very important to correct some fields which can create dangerous situation. And because of that, we think mostly about at our teacher workplace. We think in the first position, we think about supporting us with the safe, ordered, well-ordered and equipped workplace. So, for example, at our department, we implement a method called 5S standards as a basis for our safe workplace creating process. And for example, we repeat those activities almost every time we are at our offices, and we are obligated to do so at our homes, to select and remove all no needed unimportant things from our desk or workplace, or surrounding of our workplace. Later, we try to leave only those things which are needed, and do that systematically. And we have to remember about cleaning of our workplace and organizing appropriate sources to have a clean workplace and safe as well. Just we have to check electronics, equipment, and for example, we have to remember about updating our databases and software that is supportive for the data, personal data protection of us and our students as well. And there is also a norm standard of standardization. So we try to observe our practice resulting from using 5S standards and try to organize standards for appropriate, for example, equipment for our workplace or other behaviors in using different software programs. And finally, we also promote self-discipline and improvement of our behaving. There is another standard, additional standard of this method, which appear in some companies that we are cooperating with. It's 6 standards, means safety. Safety is the 6 standards method, which is organized by using different trainings, by using our result of observation of our workplace and ways of working with students. Okay, thank you very much for your attention. If you have any questions, please ask me now.
Yes, hello. Hello.
Okay.
Well, I listened to your presentation. It was quite interesting, you know, and also I think kind of connecting to what I will want to mention in my talk, the safety, you know, the safety in many ways, like from my angle as a computer scientist, I often think safety as a security. And you also mentioned, you know, that safety is also economy, because you have healthy people, and healthy people are productive, and they also have a very much better attitude. They're more positive, they're more, you know, confident and basically successful people. So you see these studies that you did, it seems that you have done a lot of kind of, you know, you put a lot of data together. And I perhaps, you know, to some extent, futuristically, would like to see a cyberspace that actually does that kind of analysis, prevention, contributing to, you know, betterment of workplace. And, you know, especially nowadays with this COVID, you see that it's just getting so, people are very stressed out because, you know, yet nobody knows what tomorrow may bring and how, you know, everything will look tomorrow. So, you know, in that respect, I hope very much that, you know, we could perhaps figure out how to connect your expertise. And I've seen also, you know, other colleagues, you know, speakers that maybe, you know, very much in physics, very much in materials, very much in many things. But there is that human factor. And of course, the value of humanity is the most essential to anything. So how do you find, as far as that collaboration with multiple disciplines, I mean, perhaps within your schools, because I know you're in Faculty of Management, but do you see that you're talking or you're working with engineers, perhaps mathematicians, or do you feel like there could be some, perhaps, improvement in that, what I call intellectual debate? Because, you know, your research is relevant for everybody, but very often, you know, people who may have bad posture in front of computer and working, you know, on a scientific Nobel Prize winning project may be victim of that neglecting the safety of their own health. So I just wonder, you know, if you see or if you tried to kind of propagate that result, or maybe presenting it, because, you know, you are expert in your field, but you have a lot of people who may not really appreciate what you do. And so it's important to be able to kind of presented to them in their own kind of discipline or realm of discipline. And I just a thought. So thank you. Well done. Excellent presentation.
Thank you very much for your remarks. I agree with you. For example, I'm responsible for the course safety management, and I had experience and talks with specialists on, we say in Poland, BHP. It means work and safety management. And it's, I know that workers used to forget about working safety. But employers are obligated, as I told you, by law regulations. But when accident happens, everyone just asking why did it happen, who is responsible, and so on. But we know we can find in every accident analysis that it's a matter, it's a problem. For me, problem means challenge. It's a matter of, for example, conducting a good training for workers, for example. Training doesn't mean only be safe at your work, safe do your work, but also about please observe what is going on in your workplace, for example, and please talk about those things with your manager. So it's a matter of communication. And why I start dealing with such a topic, because I found it also because of another analysis of competences, of technical competences and soft competences. As I know, a lot of companies now, they feel lack of people with soft competences. It's a main problem, also related with the creating safe environment at work. So I think everything, as you said, has a multidisciplinary character, and engineers and economists and socialists should cooperate to finding appropriate way of working together and giving solutions for the companies, because companies create topics for our research. That's all. Thank you.
Thank you. Thank you.
So I'm open for a cooperation. If you agree,
excellent.
Please write here addresses, and I will collect that, and I will write you if I will have any interesting project for us.
If I may, the organizers could perhaps set up kind of like a list of speakers, contact details, and so
Sure.
the talks. Thank you.
Sure, I will send you the list of participants.
Can I put a question, please?
Yes, please.
Okay. Congratulations, Renata, for your wonderful presentation. The safety is one of the areas that I make of my research too, and I like it very much. You speak your presentations about safety, because in my presentation yesterday I speak about the interaction between safety and lean, and now we call lean safety, because usually, as I say yesterday, we just see the benefit of lean on the production in the process, but we have other benefits and in the other areas, and not only in the process. And in the safety, we have a lot of benefit of with the lean. And you show this with one lean tools 5S, and as I put in the survey that I developed in some companies, and the 2 case study that I presented yesterday. And it's great to hear of you. And in Portugal, we have the same problems between the top management that you don't have make a big investment in safety, and And when this happened, then the accident happened, he say why this happened, okay? We have the same problems, okay? And I wanted to know where I can find the last table that you showed in your presentation, because it was a great information. I think it's in Norwich. What is your country, please?
Poland.
Poland, sorry. Because this information knows I can see in English. Can I see this information, or can you see some information about your presentation?
Do you want me to find the topic?
Yes, the last table that you showed before the 5S, if I'm not wrong.
My data. Okay, I try to share again.
I don't know if you publish this information.
Okay. Here you can find my data.
Okay, I save here.
Okay. If you will leave your email, I will write you my data, and you can also follow my research papers on academia or LinkedIn or other way. We can share information.
Okay, I put here my email in here. Okay. And I have
for example, my department has own scientific journal, Production Engineering Archive, and I can send you the link to this journal, and we can prepare together a good paper about lean as well, because we teach on that as well. And I may say that, for example, since a month I have a student from Portugal Technical University who is under my support within Erasmus Plus program. So we can cooperate within this program as well.
Okay. And do you have any projects? I'm available to work.
Good,
okay.
Thank you.
Thank you for sharing your knowledge and your presentation. Okay, thank you very much.
Thank you.
Thank you so much, Dr. Renata. That was really excellent presentation.
Thank you very much to everyone for any questions and contacts. Thank you very much.
I have a small question.
Yes, please.
So I gave a talk yesterday about the possibility of changing of interior, of buses and trains to take into account the COVID-like situation which we are facing, to ensure the safety of passengers and also to ensure the comfort of passengers. So we are apparently working in similar fields. If we can get in touch together to be part of this.
Do you mean using this assessment method for transport?
Yeah, but what we have proposed is a new method of interior management of buses and train wagons, so that this 1 meter distance is respected for all passengers, so that in this COVID situation, and people are traveling in safe conditions, and also it can also increase the capacity of the wagons or the buses.
I must say that in Poland, we, especially in my city, I can observe. I have own car. I don't use buses. Only my daughter uses buses. But as you know, probably as you heard, Poland has an increasing number of COVID people and we stay at home. We try to stay at home, not leaving homes and not using public transport. And there is a big problem with transport in the city. And for example, if you want to enter the bus, the public transport, you have to buy a ticket. And the problem is because the driver is separated from the passengers. And for example, our cities are poor and they try to find a source of financing those public transport. so they control passengers if they have a ticket. So can you imagine if the control entering the bus and try to control passengers who has no ticket because drivers is separated and so on. It's a crazy situation in Poland. So let's say public transport is much less used by people. I can see in the buses only 5 people maybe per bus. During the time in the past was used by around 30-40 people, the same bus. Now everyone try to use own cars or going with their friends to their companies or work places. But as I know, the situation is changeable, and people are afraid, as you know, as we feel all of us. It's a crazy situation, and nobody knows what will happen. And it's a matter also of economy. Find sources to finance things that are dying because of the COVID. So
this solution of using individual cars is not very interesting, because if you take the fuel consumption with respect to the weight of the passengers to the vehicle, and it increases the pollution for the whole environment. So it is public transportation is the future, where you use less fuel, and it is less pollution and less and it's more economical for everybody. So so this is one of the we have proposed this solution based on the WHO requirement. I can, if you want, I can send you the PowerPoint and you can have a look at it. Okay.
yeah, okay, thank you.
Thank you. Thank you very much for a nice presentation.
Thank you, Dr. Renata. Thank you so much.
Thank you very much for your questions.
Okay. And moving on, our next speaker is Dr. Samir from National Polytechnic School of Constant and Algeria. And he's going to give a talk on recent advances in functional adaptive control. And I request Professor Samir to start his presentation.
Is it shared now? Okay.
Yes, yes.
So I present myself rapidly. But I'm Professor Samir Ladassi from Constantine, Algeria. And I had my PhD in 2007 at University of Constantine. Also, with half time passed at University of Nantes. École Centrale de Nantes in France, and then I was assistant professor at University of Skikda in the northeast of Algeria, and then I moved to Constantine, where I'm a professor, full professor, since 2015. I have many papers and edited a book, and also many chapters, and many PhD students that have finished their thesis. And most of my work is focused on fractional order systems and control and their applications, and also many types of control systems like adaptive control, robust control, and system identification, nonlinear systems, and chaotic systems. So as I'm a professor in engineering school, so much of my work also is application of these control concepts and methods to practical systems in the industry. Now I will, I will show you the slides. Yes. So my presentation now, do you see the presentation?
Yes, we can see.
Okay.
Please continue. Yes.
So my presentation is titled Recent Advances in Fractional Adaptive Control. And this is, I will show you some of the results of my research team and my PhD students that have already concluded their PhD. So I am also a research director at the laboratory SP Lab, Signal Processing Laboratory of University of Constantine, Algeria, and formerly, as I said, I was associate professor at University of Schiedam. So the presentation will be organized as follows. So after a short introduction, I will present some basics of fractional calculus, which is the base of all the methods that we have developed in adaptive control, principally in adaptive control. And then I'll give you an idea on some methods developed in my research team, like fractional order MRAC, model reference adaptive control, robust fractional adaptive control, fractional order high gain adaptive control, direct fractional adaptive control with pole placements, and extremum seeking control, and then some techniques like fractionalization, and an example of application to a petrochemical process. And I will conclude with some prospects, future prospects. So we have developed many techniques, and also there are also recent techniques that I haven't included in this presentation because they are still in work, in PhD work. So the first thing is the use of PID control in industry, which is very popular in industry because of its simplicity. But what we propose actually, and many researchers are proposing, is to generalize this PID, simple PID, to a fractional order one, which means to add a fractional order integral and fractional order derivative actions. This means more flexibility and to get two supplementary parameters in order to tune our regulators and to improve the performance of the controlled process. Okay, and this PID control so is organized as seen here, and we can see that below that instead of having 3 points, it means proportional or proportional integral or proportional integral derivative or proportional derivative. It means one of these 4 points in the regular or integer order system case. We have all this surface. It means that every point in this surface can be one regulator, one PID case, particular case of PID, fractional order PID. And then it means that we have more flexibility and more options to improve our process behavior. Also, we can remark at the left of the below that the surface of stability, it means the area of stability is augmented in the case of fractional order system. That's instead of having the half plane, that everybody say that the system is stable if all the poles are in the half plane, in the left half plane. In this case, we have an augmented area of stability. Okay, and this means that using fractional order PID improves the performance and improves also the stability, the relative stability of the system. So now talking about adaptive control, that is the main keyword of our works here, or the common keyword. So adaptation is defined in the dictionary as the modification of an organism or its parts that fit it better for the condition of its environment. So Inspired by this, Drenick and Schabbender in 1957 introduced the term adaptive system into control theory. And this term had a lot of success because it could help us to deal with some difficulties like operating condition change, for example, in planes or airplanes or for behavior. So a number of commercial adaptive regulators have been already developed, and a great number of adaptive regulators in industrial use. So there is a real success of these controllers because they gave the engineers an opportunity to deal with some varying systems or varying conditions, environmental conditions of the system. And now we continue this historical review. So the first papers dealing with fractional adaptive control were focused on model reference adaptive control and began since the beginning of 2002 with the work of Vinagre and all from Portugal, and also our team, my proper work with Professor Sharef in the same time. And also some authors like Suarez and me in 2008 and 9. Then Barcena and Exabera have proposed the connection in 2007 in connections method for auto-tuning the free parameter of fraction order hold circuit in order to improve the performance of the digitally controlled systems with application to printing devices. That was one of the first applications, practical applications of this fractional adaptive control. And then fraction order adaptive sliding mode control was introduced by Efe from Turkey. And the work of Efe was devoted to the design of fractional variable structures scheme for processes that are also fractional of actual type. Also, we have developed in 2006 and 2010 some schemes of fractional order adaptive PID and PI controllers. That means that we have tried to make the fractional order PID adaptive. That means that the parameters are freely adjustable and automatically adjustable regarding the variations of the process, the controlled process. Also, in 2009, we presented a new approach of robust adaptive control using fractional order systems and parallel feed-forward in the adaptation loop. We have also proposed the fractional adaptive IMC scheme. And also, since that time, many other techniques have been developed by our team, mainly by my PhD students, and I will give an idea on this works and these works in the slides, in the coming slide. So at present, a great interest focusing on fractional adaptive control strategies and their applications in many engineering domains. Our research team has proposed different adaptive control laws based on the introduction of fractional dynamics in classical adaptive controllers, and this will be the subject of this talk. Now we come back to some basic definitions, and we could talk about fractional calculus, which was developed 300 years ago by some mathematicians like Riemann Liouville and Caputo. And that was only some mental or, that was theoretical and have no direct applications in reality. And we only could use this definitions or these concepts after the Second World War. It means since 1960 or 70. And the first works that was compatible in engineering can date to 1990 with Ustalu and Podlubny works. Now, all this is based on the definition of the fractional order differentiator that can be represented by equation 1. And we remark that here the derivative or the differentiator is of order mu, which can be real. It means that if mu is the path mu is positive, then we have a derivative. If it is negative, real negative, that it defines an integral, a fractional order integral. And if it is null, then we have the identity 1. So for this, the computing of this differentiator, fractional order differentiator, we have had many various definitions that are very close to each other, but also that help us to use for each problem, for each specific problem, some definition that could be more easy to work with. For example, we have the well-known Riemann-Liouville integral definition given by equation 2, and also the one of Caputo that have the property, the interesting property of using integer order initial values. That means that we have integer order functions for the initial values. That means that we have no problem of initialization, not like in the case of Riemann-Liouville definition. Also, we have the definitions of Greenwald-Letnikov, which can be easily made discrete. It means we can approximate with it the numerical calculus of the derivative and the integral. And to see what can we gain when using a fractional order system instead of integer system, we can consider this function of order beta, and beta could be 1. That means if beta is equal to 1, that means we have a classical standard second order system. And if beta is real, then we have a second order like fractional order system. And for the same parameters, omega and xi, when varying beta from 1 to 0.35, we could see that the step response of the system is very advantageous in the fractional order case, because we are able to improve the rise time of the system. And this means that the fractional order system have much more speed than fractional classical systems, and we could use them to improve the performance of the system. This is the first advantage, but not only one, because fractional order systems are systems with memory. That means that, like we saw in the preceding definition, the computing of derivative or integral of fractional order needs all the history of the system. That we need all the history of the system in order to compute the integral or the derivative. This makes these systems also very robust against disturbances or noises, and this is very advantageous when we are dealing with real processes and industrial processes. Now, in order to implement also these fractional order systems or integrals or integrals or derivatives, also we are obliged, or we need some approximation method, because we cannot implement them directly. So there are many many methods that was developed in the literature, and mainly we can separate some techniques in the frequency domain and identify also some techniques in the time domain. And the main techniques in the frequency domains are those of Hurtado and Shareff's singularity function approach. And for my case, our team, we usually use the Sharef singularity functions, as he was my PhD supervisor, and also he is the head of the laboratory. So we are continuing on this technique, but it is very close to the one of Ustalu. Also in the time domain, when we need to compute these operators in the time domain, we can use, as I said before, Grigorov-Letnikov definition, and also the fundamental predictor-corrector algorithm. So the approximation using singularity function in the frequency domain is used in order to implement fractional order operators and to obtain equivalent rational transfer functions that can be easily implemented there. This method is very easy to implement and is based on the approximation of function of the form 6, that is a derivative of order mu, by a transfer function of the form 7, which is a z pole, a zero pole function. And these zeros and poles could be computed with a given algorithm easily, with a given algorithm given by this method. Then also in the case of time domain, we can use the fundamental predictor-corrector algorithm. This is called also Adams-Bashforth-Mouton method, and it's make it possible to approximate the fractional order integral operator or the solution of a fractional order differential equation of the form 10. So it can help us to compute the integral of the y of the function y, and give it to the form in the form of 11. This is the solution of equation of differential equation 10. And using this algorithm, we can compute this, render it numerically computable, so we can compute this function with the regression technique, as shown in equation 12. Now we can present the famous model reference adaptive control that we will generalize to the fractional order case just later. So it was one of the pioneering techniques, and was developed by Whitaker and all in 1958. The principle of this technique is that the desired performance is specified by a chosen reference model. So the system is obliged to follow this desired model. And there are two feedback loops. One ordinary control loop, like any control feedback control system, and one in order to adjust the controller parameters, making it adaptive. So the parameter adjustment
hello, Professor Samir. We have lost your voice.
The gradient technique is based on, in our work, on what we call the Almighty law, given by, which is based on the gradient of the square error in order to minimize this error, and leading to the equation, normalized equation 4, that can give us the updating law for the parameters vector theta. And the regulator structure is given by what's well-known Diophantine equation. And this leads us to the model error given by equation 7. And this scheme is more precise, because we show here, we know here that theta is the result of the integral of the comparison between the model, the output of the model, and the output of the real process. And what we have done here is to generalize this integral to the fractional order case. So we have here integral of order lambda, and this given the new adaptation law of equation 11, and this is the new scheme of the Mach fractional order Mach control. So using a fractional order lambda in this loop from 0 to 2, we can remark that the system is still always stable, and we have a novel parameter, which is m, that can help us to improve the performance of the closed loop system. Now, for little values, of course, we noticed that when m or lambda is too small, the transitory phase becomes oscillatory. It means that we prefer values that are higher than 0.5. And the modified Mach allows high reference signal variations with maintained stability, which is not possible in the classical model reference adaptive control. And the proposed scheme is stabilized with very little values of the adaptation gain. This is also an advantage because we don't need to augment the gain, which has a negative result, influence on the stability of the system. And also, we have proposed another variant of this controller, which is based on the derivative of the output, of the process output. So we have proposed to introduce a derivative of the output of the system and to compute it like here. So this scheme represents this proposed system, and the derivative of the output y is computed here compared to the model to a chosen reference model. Why did we introduce this derivative at the output of the system, the plant? Just because we want to filter the output from all additive signals and the errors, noises, and this proved to be very efficient in simulation and also in application in laboratory. So when if you consider this plant given by the model 15 and the desired reference model for the integer case given by 16 and for the fractional order case given by 17, we can obtain these results with some random disturbance at the output. The integer order scheme give this result, while this is the same case but with the fractional order integral of order 0.35, and we can see some improvement in the output. So it is, I can see this is the integer and this is the fractional. So there is a rejection of the oscillations of the output, the system output. And in order to see it more or to quantify it numerically, we can compute some criteria, this error criteria, and we can see easily that we can the behavior or the error, the criteria is improved by half in most cases. So it goes from 17 to 8 and from 16 to 9 with the disturbance. So really, there is a real gain in rejecting the errors and disturbances. Now I can go to another problem, which is robust adaptive control. So in order to improve the robustness of the system, it means the ability of the system to respond, even if there are some variations of the parameters of the system, and augmented with some additive disturbance and noises. So adaptive control are going to show their limits in noisy or disturbant environment because becoming inefficient, because the regulators adaptation, it depends on the measures of the output. The use of simple parallel feed-forward in the adaptation loop appeared as a robust solution begin from the 1980s. It can guarantee robust stability of the nonlinear control. So the idea was to use this technique of feed-forward, parallel feed-forward, in our fractional order adaptive control in order to render it more robust and gain performance and robustness. So this is based on what we, the principle of positive real condition, which can be defined here as in definition 1. And from the definition 2, it can be used to render a system stabilizable. This means SPR and almost strictly positive real condition, which is, it means the ability of the system to be stabilized by a feed-forward, a parallel feed, using a parallel augmented parallel feed-forward. So we can generalize as follows the classical results of the fractional order to the fractional order case. Considering the lemma 1, if a fractional order transfer function GA is ASPR and we have a gain K TLE, be any gain that satisfies the equation, the preceding equation, then the closed loop system is SPR. It means that is stable for any gain that is greater than K tilde. Okay, so we can render this system stabilizable by a high gain controller. It is obvious that ISPR fractional order systems, which are minimum phase purpose systems, maintain stability with high gains. The high gain stability is important when non-stationary or nonlinear adaptive control is used because the robustness of the control system is maintained if, due to specific operational conditions, the time varying gains become too large. That this system allows us to improve the robustness of the system using high gains in the control loop. And the idea of using feed-forward in parallel with the controller plant is based on the following lemma. So this following lemma makes a system augmented by a parallel feed-forward ISPR. It means almost strictly positive real. And this means that using some feed-forward, we can render the system stable. Now, this is the SPR configuration. And the theorem, the main result is considering this feed-forward, augmented fractional order feed-forward given by equation 3. And the system augmented, the resulting augmented system given by equation 4, that is SPR, it means robust. Okay, so this scheme represents the system when combining model reference adaptive control with a parallel feed-forward. This is the new thing here, the parallel feed-forward, in order to render our BRAC controller robust. And we have here a simulation example considering a DC motor given which model is given by equation 5, and an actuator given by equation 6. Sorry. So when considering the reference model GM given by 7 and the feed-forward in case integral case feed-forward given by equation 8, we have also in the case of fractional MRAC controller, we can use this feed-forward given by equation 10. We have the following results. So the process output with integral feed-forward and the fractional also output with fractional feed-forward. And using the criteria, the error criteria, we can show that there is an improvement in performance and in robustness. And the comments that the common concept of positive real condition, which is the basic of this robust control strategy, is extended to fractional order case. We have proven the stability using analytical Lyapunov technique. The idea was to take benefits of the high performance quality of the fractional order system confirmed in many precedent research works. The stability proof of this adaptive control scheme developed for integer order filters in control literature still holds for such systems. Okay, and now a third technique also can be presented here, which is related to the second one. We have talked about using high gains in order to ensure robustness. And now we can consider what we call fractional order high gain adaptive control, which is another technique that can help us to deal with some kind of systems. So if we consider CISO plans given by the state space model of equation 1, and with some hypothesis on the system, it must be controllable and observable, and the system has minimum phase and high frequency unity relative degree. Then we can consider high gain control given by equation 2, and we can the resultant closed loop system will be given by equation 3, and the system is asymptotically stable if there exists some epsilon, positive epsilon, that's for which the real part of the eigenvalues is negative. And in the fractional order proposed regulator, we will use this configuration. So we have U is a high gain controller, a controller U is high gain controller, but the variation of this high gain is of fractional dynamics given by equation 5.2. So we can prove using this configuration that the system is stabilizable, and that we can improve the performance of the closed loop system. So this is the main result given in this theorem that we have proven using also the Lyapunov stability theorems. And we have shown that we can extend our result to a large scale of systems by using this norm instead of the one here of the square output. So we can use this norm, and then we have also the same results. And we give here a simulation result to see the difference between the integer and the fractional order case. So we can remark that using a fractional, our proposed fractional order high gain adaptive controller, we can improve the response of the system and the smoothness of the output. So this is a comparison between the integer one and the fractional order one, which is more the time response is improved, and also the smoothness of the output is improved. Okay, so the simple adaptive control scheme gives new arguments for the development of fractional adaptive PI and PID controller, because the PI we have developed then adaptive PI controller and PID controllers based on this theory or this high gain adaptive control. There are practical or particular cases of this technique. And now I can also show you this algorithm of for direct fractional adaptive control based on pole placement. So the design calculations in the direct and direct self tuners may be time-consuming and poorly conditioned for some parameter values. That means when we compute indirect fractional adaptive control, we need, first of all, to identify the parameters and then to use them for the controller. And this can be time-consuming and perhaps poorly conditioned for the system. So the direct adaptive controller can eliminate these phases, and we can gain in computing time, and also we can the system, the computer will not have some condition, bad condition schemes or problems. So the idea is to use the design equations to reparameterize the model in terms of the parameters of the controller. So if we consider more clearly the system of equation 1 and the desired dynamics of equation 2, it means the model reference system, and we can consider the two parameter control topology, STR control technique, given by equation 3. So we'll have the closed loop given by equation 4 and the controller given by equation also in equations 4. And the Dampfontein equation, which give all the scheme of the closed loop system. So we will use the recursive least square system in order to make the update of the parameters. Okay, the parameter update every time, every sample time. We will compute the new parameters of the controller, and this dipole placement algorithm is based on equation of the Dampfontein equation given by equation 10. If the parameters in the model are estimated, the control law is thus obtained directly without any desired design calculations. So it will be given, the proposed technique is summarized in algorithm 1. So given some fractional model reference, which contains the fractional order poles of the desired closed loop system, and in step 1, we will estimate the coefficient of the polynomial R and S, and then in step 2, compute the control signal from the equation of the STR equation, and then we'll get the output and repeat the algorithm till the end of the time window. So we can reconsider the example of the direct current motor velocity given by represented by the model of equation 11, and considering a reference model of a second order type with omega equals 1 and the coefficient xi equals 0.7 and a fractional order 0.4, we get these results. So this is for the controller parameter updating, and this one is the signal, control signal, and here is the output response versus the reference signal. So this is obtained adaptively with some choice of the fractional order poles. So we can say that a new fractional direct adaptive control was proposed here, and the control strategy combines the classical minimal degree pole placement with the online parameters and avoids to the calculation of the system parameters. So we have no information on the process, but we have directly the compute of the regulator parameters. The desired fractional order dynamics are imposed to the system closed loop by means of a non-integer transfer function that is approximated using the singularity techniques. And in 7 points, I will introduce also a very interesting technique that we have developed since 3 or 4 years, which is the fractional extremum seeking control. This is based on the simple principle of researching the extremum. It means the maximum of a function or a minimum of a function. And if we consider some type of functions, of criteria, performance criteria, or systems that can be represented by a nonlinear model that presents some extremum, it means a minimum or a maximum, then it is very interesting to use this technique. So our work was based on some technique proposed by Carlo et al. On 2008. In some application, the reference to output map has an extremum, and the objective is to select the set point to keep the output at the extreme values. This is, for example, the case for the solar energy systems that try to keep the system in the top performance. So every sample time we have to try to recentralize or to readapt the configuration of the system in order to get the maximum of energy. So the problem called extremum control is old because it was known, it was defined by Blackman in 1962 and was considered among the most promising future areas for adaptive control. This extreme seeking control does not need external dithering and exploits only disturbances already present in the control system. By introducing a fractional integral action in this scheme, it can lead the system to its optimal output value with an improved dynamical behavior when compared with the integer order classical approach. So the control strategy is given here. We present a new robust control scheme for the class of first order linear dynamical systems based on the approach proposed by Carlo, called dynamic extremum seeking. The aim is to find a reference signal for a dynamical system such that an unknown cost function of its output is minimized or maximized. And we address the problem of finding the global minimum of a static unknown map, G, whose input is affected by a disturbance T, D of T. Okay. As shown in the following figure, this is the block diagram of the scheme and the consideration. Okay. And using this assumption one, the unknown map is locally Lipschitz and locally bounded. And in the considered extreme seeking synthesis problem, we assume to exploit a problem signal Q, which is constrained to act on the function G through a scalar dynamical system having the following simplified form. Equation 1, where epsilon is a positive scalar. Then the input of the output and the output of the static map G are assumed to be two measurable signals given by equation 2. As in the initial integral order control scheme, there are some boundedness conditions on the disturbances, of course, signal exciting the function G to be fulfilled as stated in this second assumption. And then the control strategy implies also two input-output ES laws assigning Q, assuming that the signals in equation 2 are available. And we have to make a strong assumption on the ability to obtain an ideal derivative of the input and the output of the unknown map G, because we need to compute the derivative of these signals. It is clear that for actual implementation, we will use approximation of the signal tree. And the proposed control scheme is obtained by introducing a fractional order integral S power lambda to the initial control scheme as represented in figure 2. So this is the proposed scheme, fractional order scheme, and we remark here at left block the use of a fractional order integral of order lambda and saturation nonlinearity in order to make the signals bounded and limited to some amplitude. So using this technique, the Planck reference Q is generated by the following dynamic, and the control laws becomes given by equation 5. This is the control, adaptive control law for the parameters theta, with K1 and K2 positive and fractional order lambda in the interval of 0.1. The block diagram of the corresponding closed loop system is represented like I show in figure 2. It is well known that the introduction of fractional order integration in adaptation algorithm allows to increase the reference amplitude variation domain. That we have said this in the first technique of model fractional model reference adaptive control, and the selection of Q as in equation 5 here guarantees that theta is bounded by K1 on S power lambda, an appealing property of probing signal since it avoids exciting possible high frequency dynamics, which is a practical engineering problem. Moreover, whenever necessary, the method allows to meet the rate saturation constraints of the physical device. This is a comparative simulation example for this new technique. If we consider the function of the system given by equation 6, and this simulation adjustment, we will obtain for the extremum seeking control of energy system this output, and we can see that the output time response is improved or varied following the order of lambda. So we can, the order of lambda is a new parameter of adjustments for the system. And it allows to improve the response and to get more energy and more power from our system. Here is the result for the output. For in case of lambda, the best case, which is given for lambda equal 0.4. And we can conclude that the best, this result illustrates indeed the role of the fractional parameter as a new freedom degree for adjusting the rate of output convergence to the optimal value, and then to gain more power and more energy from our PV panel system. Okay. And now I go to a new concept that we have proposed also when we were trying to improve the robustness of a control system that is always already available. So is there any possibility, the question is there any possibility to replace some regulator, for example, a PID regulator or PI regulator, by an equivalent controller which can behave betterly in presence of disturbances or noises, additive noises, but maintain the same performance in the case of in the ideal case. So the idea was to fractionalize the system. We can get it from this simple example. If we consider this integrator, one S on S, and we can say that this integrator is the product of two fractional order integrators. It's very simple idea, but we called it fractionalization because the product of these two blocks is equal to the initial block, integral block. But the behavior of the only block, integral block, is not the same. as the proposed two blocks, because when approximating the first integral and the second fractional integral, we will have a filter, a high order filter that will act as a filtering system to the internal signals of the control system. This is what we will gain from this fractionalization. I said that we're trying to see everything as a fractional system, because even for existing integer order systems, we can replace them by this combination and then get some new performance features or new results that are not possible with the old situation. So in the ninth point, we will propose an application of fractional order control to a petrochemical process, which is a set of boiler tubing at the refinery of Skikda, where I was working since before 2013. And Skikda is one of the principal petrochemical industrial zones in Algeria. So the process modelization is given here. We have the scheme of the boiler turbine system, and the process modelization can be obtained easily, and we get these equations for the state space representation. And then we have these constraints on the outputs and on the inputs. The control problem is the nonlinear system has to transit from an operating point to another with respect to the control constraints, and the system is designed to follow the different reference as set points. So we will consider here decentralized, what we call decentralized control. In the decentralized control strategy for MIMO process, each distributed energy source works freely, utilizing measured local signals. Subsequently, no source is the reference, and all sources are at a solitary control level. Use a set of mono-variable feedback control loops. So removing or including a source makes no aggravation in other source operation. And subsequently, better reliability and flexibility can be accomplished in the process. So in order to apply the fractional order model reference of this control to this system using a fractional integrator, we have to guarantee this fact. So minimize the cost function, matching the process dynamics to the reference model, respect to the constraints on the control inputs, and minimize the effects of indivisible interactions. It means decoupling of the variables. So given using these different settings, we can obtain the results of equation of this figure. So in blue is the reference, and the output of the model is in green, and in red the output of the system. So really it works very well, and the output is practically equal to the one of the model, desired model. This is the control, the different controls, and this is the electrical power obtained from the system. And in case of reference tracking, when the reference is varying like here, we can see that also the system is able to reject these disturbances and to follow the reference. And in the 10 points, we can conclude. I have avoided to present other techniques that are ongoing or that are recently published, but still we are developing some variations or some special cases of these techniques. So perhaps we could present them in next or future presentations. So actually, there are ongoing, much more ongoing research projects. For example, concerning fractional order nonlinear system with chaotic behavior, we have many results on fractional feedback PID controllers and adaptive sliding mode synchronization and fuzzy adaptive control applied to the case of fractional order chaotic systems. Also, we are working with the two PhD students on identification techniques for fractional order systems, mainly nonlinear systems, and also online estimation and observation of fractional order systems for adaptive control. We have a thesis that was defended last December by a PhD student on fractional adaptive model predictive control, which is also very promising because it's in the classical case, model predictive control is used popularly, is very popular in the industry, and proposing an improved variant of this technique to industry will be welcomed and will help us to improve the behavior of these practical systems. Also, we are working also on optimized adaptive control, which is a combination of adaptive control and optimization of optimal control in order to get the best of the best. It means adapt the system and get the best possible output. Also, we are trying to apply fractional order adaptive control to time delay systems and to give improved robustness and the performance systems output for these systems, even if the delay is unknown or varying in the time. A recent work also concerned adaptive fault tolerant control in aeronautics, and we had the acceptance of a publication in a well-known journal just yesterday for an adaptive controller that can behave with a good performance, even if some actuator is in a fault. It means that we lose control of some, we lose a source of information, and we can replace it by a redundant system and get a continuity of the system or of the behavior. And voilà. So for the future, we can try to implement all these techniques in real world and get perhaps more value of these results, of research results in industry. So many new fractional order control schemes were proposed with interesting performance when compared to classical schemes. A beginning solution for the problem of stability analysis of fractional adaptive control, and many other works are in progress or under review. Some open problems and future works concern design and investigation of other adaptive control configuration, stability analysis of these techniques, application to real laboratory, and application of this control algorithms to a larger class of fractional order systems like systems with delays, nonlinear, chaotic, and multivariable. And for these preceding works, we have had many collaborations, especially in France with the laboratory of Nantes, but also Lille and Grenoble, and also in Chile with the Professor Manuel Duarte Mermud, and in KSA with Professor Mariam, and in Malaysia, Tunisia, and Germany also. So there's very interesting developments in future, and I thank you for your attention, and please, if you have any questions or comments.
Yes. Thank you so much, Professor Samir. Thank you for your
Thank you very much. You're welcome. Thank you.
Question, okay?
Yes,
yes,
please.
Yes.
Okay, thank you so much for your suggestive talk. Okay, could you please show me the PowerPoint presentation sheet whose ID number is 10?
Yeah.
Page 10. Yes.
Okay. So
this is the first.
The point 10.
10th page, please.
10th page.
10th. Yes.
This one?
Oh yes, this one. Yes, thank you so much. Exactly.
Yes. Yes.
This is your nice result proving your method has succeeded in obtaining good
performance,
good effect. Perhaps I think, but perhaps I think how long does it take for refining, for obtaining more final result? For example, the more fine result we want to obtain, the execution time will be required. Perhaps I think so.
Do you talk about the computing time?
Yes, exactly. Computational time. Yes, execution time.
Yes, of course. This problem computation is relatively old, because now we can make very complex calculations in a very small time, because of the development of the processing tools. So this is one fact that encourages to use fractional order system, because in beginning people were pessimistic, because approximating approximating a system like this could lead to a system of order perhaps 15 or 20 in order to be more precise. But actually, so it was very complex and difficult to deal with. But now we can deal with the orders of even for 100 order, no problem, because the capacity or the ability of the systems to compute is more powerful. So we can get these results in the same time, practically in the same time of the one with integer order. And we can improve.
Wonderful.
And we can improve the performance in the same time. So there are no problem of time. I'm working in adaptive control. It means in real-time systems, with real-time systems. And the problem of computation is very important. So I thank you for your comments, because when we work offline, the problem of computing is not so important. But when we are working online, that means the system have to compute the input or the control in a simple time that is very small. So I think that's actually the problem of computing time is not very, affecting or very important. That's important. So we can, as we remark here, there is some real improvements for the performance and real improvements in the robustness. I talked about half time about robustness of the control system. And of course, the computing of these tools or these fractional order systems is not so time consuming.
So complicated form, yes.
Yeah. But the form is complicated, but there's an algorithm. So it's not the researcher that will, or the engineer that will deal or with this form. It is used. We use an algorithm that computes automatically the equivalent transfer function.
Thank you so much.
You're welcome. Thank you very much for your interest and your question. Yeah. Okay. Thank you.
I have been so surprised to know the execution time, computational time, which will be required for the feedback, repeating repetition of feedback is not so so difficult problem. Yes.
Yeah. Okay.
Thank you so much.
This is the case. Yes. Thank you. Okay. Is there any other
I
problem?
enjoyed your talk. Thank you so much.
Thank you very much. Yeah, it was a pleasure. Thank you. I hope that we'll meet other times in future. Thank you very much.
Yes,
Thank you so much.
Our next
your
conference
talk has been so fruitful. Yes.
Thank you.
So fruitful. Thank you so much.
Okay.
Our next conference is in August.
Okay. Yes.
Thank you.
Okay.
And request, our next speaker is Professor Babulak.
Yes.
And I request Professor Babulak to start his presentation.
Very well. First of all, let me see if you can see my presentation.
Yes.
So first of all, thank you very much for kind invitation and also for the contributions. I look at your presentations and I must be quite honest, it was very, well and relevant, all these talks. When I was thinking about this applied science, research, and technology, then, from my angle, I'm very much interested in what's coming because, like looking at the whole technology development, and we are, through, say, last century, the very much so was about all this miniaturization and Ethernet and cyber AI and robotics. So last year, starting with COVID, have changed fundamentally almost everything, the way of life that we take for granted. And I thought, I use this kind of brief presentation just to bring those ideas together. So, looking at all these trends in communication, it's all about getting faster, getting accessible almost anywhere at any time for anybody. And that automatically, enhances that concept of smart with ultra smart, because I often wonder when people say, this is a smart cell phone. Well, and we can talk about, but in my humble view, I have not seen any smartphone yet. Did you? Did anybody see any smartphone on the market today? I mean, smart, truly smart. Okay, so, that concept of what is smart is often kind of misunderstood, or it's represented by functionalities and all these different features and fancy kind of things. But my question is, could anybody steal your cell phone? And the answer is yes. Could anybody hack to your computer? The answer is yes. So ultimately smart technology would be that nobody can steal your cell phone and nobody can hack to your computer. And of course, this is something that, giving that connectivity and application and connecting all these devices, IoT, Internet of Things. So we'll see in manufacturing industry, in health, in education, academia, all across, in physics, that ultimate direction to automate. And that would create that fully automated cyberspace. Now, apart from all this, of course, as a computer scientist, we always wonder, how do we solve the problem? And of course, starting with the very concept of algorithm. The AI is basically a smart algorithm solver solution where basically that human intelligence, human reasoning could be applied or could be developed within the machine learning systems and machine learning from machines and creating all this concept of AI or robotics. Now, with robotics, there are three laws, and everybody would agree that law number one is robot must not hurt, and also a robot must basically perform a very specific task reliably and safely. And we've seen presentation on safety and reliability. And at the same time, as all these machines become so ubiquitous, so they create so much of data, and we need to be able to process, to store, to manipulate all these data, and yet make them available 24/7 to anybody, anywhere in the world. So that cyber becomes reality. Even the fact that we are now meeting and talking virtually, it's kind of proof that there is a internet that actually connects people, and we share, we learn from each other. We also learn from other sources available via net. Now, very often with robotics, we see Sophia is one of the intelligent robots, and of course, there are, other versions of very humanoid look-like robots that can actually even talk, that can actually even reason, and they even have, to some degree, a features of human. So that is something when we, coming to AI, it becomes almost scientific, and you wonder how far the technology will go. I'm very happy to see the technology going very far if it is applied properly. And of course, given COVID, one wonder, could we bring all this big data, AI, machine learning, all around health and creating a better electronic health record, creating a telemedicine that would be actually able to prevent and protect and perhaps even heal humans against any potential virus or bacteria or disease. So of course, this lecture is more, kind of like a inspirational lecture. And it just to give an idea if there is, or there are ways of bringing together all this knowledge in modeling, motion generation, control, humanoid robots that would actually be applied. I give an example. Some years back, working with colleagues in Tokyo, we saw the lab where they were building fully automating kind of environment for disabled person. And of course, that person cannot talk, they cannot really do much physically. And so there is that computer-human interface or some kind of contact that actually that person could initiate a very specific process. And so I think that physics-based animation and also perhaps some biomechanics would be very much valuable in that concept of helping improving lives of people who may be seriously handicapped or are basically tied up to the wheelchair. Also, looking at the COVID, so one wonder, like if you look at the John Hopkins map, the numbers are increasing every day. And there's so much effort in kind of fighting that battle with vaccination. There are yet different kind of vaccines, and there are different theories and different kind of studies that may favor one or the other, or also kind of trying to figure out if we can definitely establish a framework which would say, okay, at this moment, we have methods, we have tools, we have specific medications that we can basically eliminate any virus such as COVID. So in that, very dramatic times, I think the fact that we've met, it shows that there's a lot of people, and I say individually, from my view, very often there's so many expertise in very specific field, but often we don't see often very that connection where, for example, somebody who is very, much involved in physics or material or electrical engineering, that would actually be able to work with somebody like sociologist, somebody like, business manager, or basically trying to figure out that we can create that dimensions of humanoid technology that actually brings together and work together in all these fields for benefit of mankind. So with that very kind of simple, overview, I felt like, the whole idea is to kind of look at if we can promote, if we can create some research, innovation development, where we yet would build the cutting edge technologies such as humanoid robotics, AI, smart cyber systems. And also that this system would contribute to saving human lives and basically, contribute to decision makers in the nation and worldwide. So it's a very, very brief presentation. I know you all had a long day, and I felt like, kind of last minute connecting to the group. I felt that this is kind of just a very, very brief intro. I got, as professional, as a professor and researcher, I work in many different on many different platforms with colleagues all over the world. And I hope very much that we can, together, we can create that smart, truly smart, life-saving cyberspace. Thank you. And if there's any questions, any comments, I'm happy to.
Thank you so much, Professor Edward. Thank you so much for your presentation.
In the beginning, Professor Babulak talked to us about smartphone, which is used every day by people. And he said, really, is there really a smart cell or smartphone? Because in practice, there are only applications and the device is not really smart. But perhaps also even when we develop smart things like smart cities or smart phones, etc., we'll have the same problems because the one who will steal try to steal this cell phone will be perhaps smarter. So this will be always smart is relative, is not absolute.
Agree. Yeah, well, like I give you an example. In some of the graduate classes, I would walk to classroom and I say to students, please give me your cell phones. And I say, don't worry, I break them, I bring the hammer and destroy them, so don't worry about it. And you can imagine the reaction. So there are two things. One is dependency. People are completely dependent on my cell phone. Like it's almost like, becomes, it can destroy a relationship or God forbid, some people are so involved. And these addictions, it's not, I don't say it's wrong, but we all kind of coming to that level when we just got used to computing and depend so much on computing. But the fact is, there is still that human spirit, human dimension, when reasoning and values of humanity are quite difficult to be implemented in technology. And so that technology should not mechanize our relationships, should not favor, whatever, say, in banking, if you take an old lady and she has a bank account and she may not read the small script, but if she overdrawn, then of course she gets penalized. And there are many, many different examples. And we also use what somebody mentioned, competent. What is it to be competent? And so, of course, I think that is something where, the big cell phone makers are making billions of dollars because it's a huge business. And every time there's a new upgrade, version 11, version 12, and then version 2020, whatever. But I think at the same time, you also have to look at how that technology will basically contribute to human safety, human well-being. When you have when you invest 2,000 in a cell phone, is it going to help with your health? Is it going to help you with your cholesterol? Is it going to help you with your relationship? So of course, it's kind of, you know, I'm trying to connect that, what is called social impact of technology with technologists.
Mm-hmm. That's good. That's very nice. Thank you. Thank you for the explanation. Yes. And this presentation also. Nice.
It's very brief, but you know, I remember working with colleagues in South Korea. We traveled to California, and actually the University of Los Angeles, California, UCLA, they were, the Intel invested some $50 million to study the social impact of technology. And that was 2012. So you can imagine that, you know, there's a lot of people who take interest in kind of looking at this dimension that is not necessarily technological, but it's more like a human factor.
Yeah.
When, you know, you look at the droids and all these new technologies that could actually spy on you 7/24, you know, all the time. A Smart DAS project and many other, there have been excellent projects in military and many other applications, but the thing is also, how does it contribute to the betterment of mankind? And I would say, as an educator, as a scholar, I wish that every child on the planet is safe, that they have beautiful home, that they have good quality education, that there's no, you know, somewhere, because you live in Boston, you have better life than somebody who lives somewhere in the middle of Africa or South Pacific. So I may be idealist, but that's what I am. I'm a scholar and I like to be idealist, and yet I have a PhD in computer science. So I'm challenged myself, you know, how to use that knowledge for betterment. And of course, all of us, you know, you all are experts in physics and mathematics. And I say, you know, I'm so glad that, you know, working with brilliant scholars and having company like you, it's so wonderful.
Yes,
so
thank you very much.
Hopefully through this very brief introduction, we may start something, or, you know, contribute to something greater than just technology.
Okay, that's good. Thank you. Thank you very much.
You're welcome. Thank you. Thank you. All right.
I can plus one another question, or perhaps a thought. Is the objective of smart things, for example, smart city or smart, is it to render the human being inactive? That means smart house do what does what normally the people inside do. So it does it for them. So also the smart vehicle, the smart I don't know, the smart transport. So is it the finality of all this? Is it that people will live without doing anything, without computing, without thinking? And
well,
this is not good.
You're right. I mean, you know, to some extent, for example, smart transportation like Vancouver, British Columbia, I worked in Vancouver some years back. It has a project which is called e-transportation. And that is, you know, facilitate, like if you have a busy schedule as a professor and you want to meet somebody socially or business-wise on the other side of the city, then that system should help you to optimize your route, you know, if you travel with the public transportation. Take this metro, jump on this bus, etc., etc. So that is a practical application. As far as smart house, you know, having devices that actually control your, you set up all these VC cameras and all this, refrigerator actually flash if you have not enough milk or whatever. So, but you're right. Then what people don't think often about is that this smartness requires connectivity. In other words, electromagnetic field, because everything is digital and everything is transmitted. So you see, like, young mom would put a video camera into baby's room right on top of the cradle. And yet the question is that video camera or that device in to some extent transmitter and receiver, from the electronics standpoint. So there is that electromagnetic energy. And the question is it good for the very young baby to be exposed to electromagnetic field, and to what extent. So these are, kind of discussions where, of course, 5G is here. I went to Surrey in UK, and surely the colleagues in Surrey are one of the top research center in 5G. And I was quite impressed, but I also was quite worried because I said, my gosh, I'm going to get exposure to radioactivity like I never did before. Because, the intensity of the signal is much higher. And so, of course, this is where, again, we take a specialist who develops the communication system, and you take a medical doctor, and the question is, can they work together? And in the middle, you put a little baby. What is best for that baby, for that baby's future, as far as health, as far as, of course, technology is perfect for education, for accessing knowledge. But at the same time, if they keep their cell phone too much long by the ear, then we have cases of cancer, and we have other kind of medical conditions. So, it's interesting that kind of medical, and I think Dr. Renata mentioned, in their studies, it's all about that creating working environment, or even social or recreational environment. But it's challenging because, it's hard to say, oh, let's decrease the signal, then we lose the connectivity. Intensity, as you know, in physics, mathematics, it's all about amplitude. It's all about, getting most effect. Yeah. But there's also pros and cons. And anyway, so in that respect, I don't really have the answer. I have some observations. And, this is where I often like to bring people together. I get involved in, different discussions on the US, Canada side, and also European side. And I also work with colleagues in the Middle East, because, there is something that brilliance, as far as scholastic brilliance, there are children right in Algeria, they are brilliant scholars. And they, if they get a proper training and education, they could be the best minds on the planet. Same in Poland, same in India, same in anywhere, Korea, Japan. But the other thing is also that we have to create that, what I call a scholastic pool of masterminds that will also contribute to the ethical norms, or some kind of professional norms. When technology is developing, but technology is developing in service of people, not people becoming abused by technology, but on the contrary, technology must be just a tool for betterment of life for everybody.
Yes,
anyway, so I'm an idealist. Thank you.
That's good. Nice thing. Thank you very much.
You're welcome.
Yes, Dr. Renata, please ask a question.
Yeah, and maybe it's a question to all of you. Especially, I'm just curious about the situation in USA or in Japan, because here in Poland we are forced to stay at home because of crazy statistics in COVID, and because of no way to find any appropriate solution by our government, who seems to just to use this situation to implement different stupid solutions and decrease the number of educated people. And I can observe at my university, and I can observe by talking with other teachers at universities, that that students used to stay alone on the other side of the computer, and they are not interested in even in showing themselves. For example, here, we cover sometimes a camera and just to what? To cover what we do during when we are listening or not listening. So, for example, yesterday I saw somewhere on not Facebook, LinkedIn maybe, there was one lady dealing with training, and she asked in public, do you use your camera during your courses, trainings, workshops? And she asked why people close cameras. we know that during the teaching hours, contact with other people is very important. Even I can imagine contact with other people during conferences. Believe me, I worked for 20 years at university, and for 10 years, I'm very active on different international conferences. I used to go somewhere and talk with people, and today, for example, confirm that I'm open person and I like knowing other people. And as Professor Babulak, I love joining to any people who talk about important things and finding joint issues. But the problem of today is related with closing us in boxes called computers, in a smartphone, in any machines which close our mind. For example, everything is closed in the machines. We are not able to count. For example, our kids, my daughter, who is 16, used to stay all day at home using e-learning courses, and she is all the time at home. Even I ask her, go for a walk, make a break. She doesn't need it because she rests by, for example, watching Netflix movies. So Jesus, I afraid that we will get students in the future as box machines, as people without all minds, all will, which is very important in what? I think is very important for a human, for a living, for relations. And relations are very important, very supportive for creating anything new. So maybe it is on the purpose of big companies like Microsoft and so on to close people. I'm just thinking about it because until now, until 2020, we were open. There was no chance to stay alone somewhere at the end of the world. Now we are free, but not free at all. It's my conclusion.
Dr. Renata, if I may, thank you. I mean, you said so many things that I surely think, everybody agrees and everybody kind of observe. This is why I often say, where I am in my career today, I feel like, there are times when we want to kind of build up our profile and be successful and travel and present and publish and all this. But also, this 2020 is a reflection, and that kind of brings the value that I often say, as scholars, as educators, as researchers, we are like brothers and sisters, and we must continue to remind ourselves that you could be my sister, I am your brother. And regardless of where you are on the planet and whatever, is because we are on the same boat, and our mission is education. It is to inspire, is to cultivate a mind. And of course, you see the power of technology when suddenly you mention Microsoft. I wish everybody well, but I often say in my classroom, in almost any classroom, that students I have may become much more successful than Microsoft. Mind you, dimension of Microsoft success is also philosophical. What is it to be successful? But yet we come to that common human sense, and your grandparents, my grandparents, everybody's grandparents were people who didn't have much education maybe. They had a very simple, conditions of living, and yet they had so much wisdom. And that wisdom, that common sense, this is something where I believe that we have to promote and also be strong, be reminded of ourselves that we are not alone, despite of being perhaps in that current scene. US, for example, has the largest number of COVID cases. And I tell you this, our neighbors went to Florida and they say they haven't seen nobody locked down. Everybody goes anywhere, everybody is driving, everybody's shopping, everybody's going to places. And actually they have less COVID cases than people in some other states. So it's all kind of, you know, and I'm not medical doctor, so I cannot make a proper judgment, but it's all about, you know, something that we have to overcome that particular COVID crisis. And part of it is, of course, medication, vaccination, but it's also the attitude. If you feel that you will be strong, that you will be healthy, you will be healthy and strong. As soon as you start to doubt yourself, as soon as you know, we get onto this kind of what we call public depression mode, then of course people are breaking. And, you know, I feel sorry for your daughter because, you know, young people, children, they need to socialize. They need to be exposed. They need to even hug, and they need to talk and play and go to the garden and climb the trees and just, you know, jump in the river. But of course, if it's clean. Yeah, so I think this environment that we live in, it's important that we kind of, as parents, as scholars, we also educate our children and students, and perhaps work with our colleagues, listen from, because, you know, we all can learn from each other in so many different ways. But it's important to be positive, to have that faith that it's going to be fine. It's just yet another crisis that and humanity have overcome so many. And so I think it is important to kind of stay strong, and at the same time to create the ways of, you know, like educating your daughter, trying to figure out if you could perhaps use different strategy, or, you know, like we are now here and we have all different backgrounds and all different kind of expertise. And yet we are all united because, you know, we all kind of feel that, you know, health is essential and it's good. And very often, you know, you can be billionaire if you don't have health, it doesn't matter much. But I think our contribution is to contribute to betterment of mankind and educate the thinking, the way young people think. Make them, you know, use that time. For example, I have learned, you know, humbly put, 16 different languages. And when people say, oh, I'm impressed, I say, well, I'm completely confused. And I feel like I'm at the beginning of everything. Yeah, I didn't use time very well. I should learn much more. You know, one of the language inshallah, fala Arabia, yeah, alhamdulillah. I wish very much I can learn Arabic. Yeah, or Ohio gozaimashita. Yeah, or, you know, Hangugo Mari Chogum Ashiarayo. You know, and all this fantastic Hindu. I don't even mention Hindu. So in other words, I found there's so much to learn. And so we should use this time, and, you know, as we are learning in that field of research, but we should also help our young people in the community to learn and say, okay, you know what, maybe you could look at and just keep learning French, combine languages with mathematics, because, you know, Iranian proverb says, people who learn mathematics, their mind will be always young, because the mind is like a fresh water, you know, it keeps moving. And when you, very often, even people under stress, I recommend that they start reading algebra book or calculus book and just go through one concept. And what we see, fractional calculus, it seems, you know, so many formulas, but it's actually not. It's very simple. It's beautifully connecting all these wonderful concepts of mathematics that apply in real world, in real, you know, science and real engineering. So I think, you know, it is to create that kind of, you know, this is the mission. We are on the mission. And now we must be reminded, but we have never been more, our mission have never been more important than today. Whatever we do, we always have to inspire, motivate. And whatever negative information or whatever comes, we just rise above it. It's like a cloud, it will overcome. Because beyond all of this, there's always blue skies, and there's always heaven, and there's always something that is much bigger, greater than humanity itself. So we must not surrender, you know, we must not surrender, must be strong. And also encourage each other, you know. So on that occasion, I like to say to organizers, thank you. You know, it's wonderful. I've seen you have a big heart. You have bring us all together from all over the world, because, you know, and maybe at the very beginning, you didn't know exactly how this will end, how this conference will develop.
Yes.
But now we see that we actually are reaching out, because we are brothers and sisters. I may be born a little bit sooner, but, you know, there are people who were born before me, and they are, you know, younger, older. Age doesn't matter. What matters is the idea and direction that we take in life. Yes. And that direction is important because, you know, there are people before us that they walked that line and they carried these values and they carried the challenges. So I say, you know, to student, to any colleague, we have to be reminded of that, being humble and being grateful, and yet being strong, courageous. Continue with our inquisitive mind, asking questions, you know, and this is why I hope naively perhaps that as educated men, if somebody said to me, this is how it is, well, I say, okay, but, you know, I like to investigate. And then I kind of give my signature, I put my signature on it. So we don't take anything for granted. You're right, a lot of people, decision makers, I would not make any judgment on their scholastic or academic capabilities, but we see that very often, you know, it is a wisdom that is hidden in simplicity. Because what you find that, you know, you go to your grandparents and you say, Mom, I have so many diplomas, I have so many so what, and she would say, or your grandmother would say, well, and how are you as a human being? Are you happy? So that is, it's philosophical, yeah. And I think this is where we all come to. Professor Samir agrees, you know, I look at, you work so hard, you know, studied so hard. Professor Shigeo, yeah, it's always about so much work, so much work, so much work.
Yes.
And,
exactly.
Yes,
exactly.
Yes.
Yeah, please comment.
Human mind seems to disappear. Yes, time by time, I think so.
Yes, we have to, and we have to be reminded also about us, maybe challenging it is for us, but we have to create, you know, I don't say I feel sorry, but I really feel that it is not correct, not just, because young people, children, this universe belongs to them.
Yes.
It does not belong to us. They have to have their future, and they have to be very positive, enthusiastic, and they have to go on and travel the world and explore and make friends all over the world. You know, that's what is important.
I think, however, yes, please.
Yes, please.
I think, however, specialized our smart life, yes, smart city, such as, yes, smartphone, yes, the extension of, yeah, as you mentioned, but has been progressed. There still exists a large and wide boundary exists between our, yes, human hearts, human way of thinking, and, yes, mechanized, yes, our social life. Yes.
Agree.
We must keep our human heart so safe, I think.
Absolutely. Ohio gozaimashita.
Oyasumi nasai. In Japan.
Yes, please, Dr. Rangathan.
So, if you permit me, I will make a very short summary of this very interesting meeting. We've been together for 2 days.
Yes, please.
27 talks, 16 yesterday, 11 or 12 today. There have been participants from 14 countries: USA, Poland, India, Italy, Japan, France, Algeria, Taiwan, Belgium, Qatar, Turkey, Lebanon, Canada, and Portugal. The topics have been extremely large: artificial intelligence, robotics, sustainable concrete, signal processing, fatigue, crack growth, surviving the COVID, resource management, cancer, etc. I'm quite happy that all speakers respected the allotted time and we had good discussions. And we should thank the organizers for having made this event possible. Hopefully we get together again on another occasion.
Yes, our next event will be in August 27 to 29. And I invite all to join us again and make it again a successful conference. Thank you so much. Thank you. Thank you. And Dr. Akashi, would you
Thank
like
you
to
very
make
much for inviting.
Yes, yes, thank you.
Yes,
Our pleasure.
thank you
Our
very much.
pleasure to have you all here. It was really excellent presentations from all of you.
Thank you very much.
I enjoyed a lot. There was a lot of knowledge sharing from you. And
I really appreciate your preparation for our successful conference. I have been so honored by being invited to this wonderful conference. Thank you so much.
Thank you so much.
Professor Rangana-san, I would like to deliver my hearty gratitude to you and all the other members of the local organizing committee. Thank you so much, Professor Rangana-san.
Yeah, let us hope the time will come that we will be going together to Japan, to India, to Algeria, to Poland.
Yes, you're welcome.
Italy and all these places.
Yes, exactly.
And then we will just look back and say, oh well, that was 2020, 2021. Now we are in much better times.
Okay.
Thank you.
Thank you all. Thank you so much.
Thank you very much.
Thank
And
you very
Thank you very much.
please feel invited to Poland, to my university.
We will.
That's good.
Thank you.
Sure.
Dziękuję. Dziękuję.
Oh, great. Thank you. Bye.
Bye.
Thank you.
Thank you.
Thank you all. Thank you so much. See you in August again.
See you again.
Thank you. Thank you all.
In the very near
See you.
future.
Bye.
And
Bye.
bye-bye for all.
Bye bye. Good night and good morning. Good afternoon.
Yes. Bye.